A big hi to all of you. Trust everybody is doing good. My best wishes go with you. So here we go. So today we are doing a lecture on permutation and combination part 1. We divide this into two parts. So maybe the first 1 hour I'll try to keep it as simple as it could be, in the sense like as fundamental as it could be. So then once we are comfortable with the fundamentals, then probably we will scale it up, right? So that's how we go about this. So therefore, maybe the first 1 hour I'll talk about the importance of fundamental principles of counting, which is really, really important, because once we are clear with the counting algorithm, doing the variations is never a problem, right? So it's as good as a foundation. So technically what happens is permutation, combination, probability are last few chapters of any high school textbook. Therefore, although there is always a little bit of mention about permutation, combination, probability in the high school, but we generally kind of kind of ignore it. Sometimes the teachers also would be under pressure, therefore they rush through it. So all these things kind of happen. So thereby we miss out on certain counting algorithms. So I'll deal with a very fundamental one for the 1 hour. So but then it is very important as well. It is not just fundamental, it's really, really very important. It could be a nice refresher for us. Let's see how quickly we can wrap up that basic part of it. So once we are done with this, then we will look into the application. Slowly, gradually, we'll unleash one by one parameters. Maybe when we take up the next lecture on permutation combination, sometime after a few days from now. So then probably already we will also look at the deeper application with respect to this particular topic, right? But nevertheless, if you look at the questions built on permutation combination from the exam perspective, that's a management entrance exam perspective, they're really, really fundamental, right? It's not that they are going to twist too much. No, not absolutely. It is just that, okay, our fundamentals need to be in place. If that is in place, probably we'll be able to handle the application, right? Okay, so if we look at this, couple of things that we will be using in this class could be the symbol factorial. We'll be using the notation factorial through our lecture. That's one. Second thing, of course, as I said, the comfortability with respect to the two principles of counting. There are technically two principles. One is the rule of addition, the other one is the product rule, right? Product rule and addition rule, these are the two rules we kind of use it. So if I'm comfortable with these three elements, that is the meaning of the factorial, the meaning of using the fundamental principle of counting, the addition rule and the product rule, we are kind of like, no, that's a far more, that's a basic foundation for this entire lecture. Here we go, friends. Let's get started on this note. Let's get on to the lecture. So let's start exploring them quickly. So n factorial, right? Now, so we all understand that what is n factorial. I know it is very elementary what I'm talking about. So n factorial, we all kind of know. So there is, therefore, already there is nothing much that I could deal with. So let's say already I want you to write 5 factorial. We all know this is 5 into 4 into 3 into 2 into 1. Perfect. All right. So if I ask you to write 3 factorial, good, that's nothing but 3 into 2 into 1. You may say that, hey, can I write the other way around, 1 into 2 into 3 into 4 into 5? Either ways, it's fine. Product of the first 5 natural numbers, right? That's 5 factorial. 3 factorial, product of the first 3 natural numbers. That's 3 factorial, right? Yeah. So that's how you'll be writing. So for example, if I ask you what is 3.5 factorial? What is 3.5 factorial? Think about it. What is 3.5 factorial? Good, your teacher said that the factorials are countables. All right, because what is that factorial, etc.? What is this chapter about counting? While counting, you will not count. I can do this activity in 4.5 ways, 3.5 ways, etc. The counting always is a whole number, right? Whole number. You can say no way. No way means 0, right? No way is fine. Or 1 way is fine. 2 ways I do it is fine. 3 ways I do it is fine. You won't say that, okay, I could probably do this in 3.5 ways. No, you don't say that. Therefore, factorials are defined only for whole numbers. Your teachers would have very clearly told in the high school, factorials are defined for whole numbers. 3.5 is not a whole number. Therefore, 3.5 factorial is not defined in the sense that, therefore, is 2 factorial defined? Yes. All right, we know that the value is 2 into 1. Is 1 factorial defined? Yes. All right, now this is nothing but this is 2 into 1. Similarly, 0 factorial, that's the point. 0 factorial should be taken as 1. From mathematical perspective, 0 factorial should be taken as 1. Factorials are defined for whole numbers. What is the smallest whole number, friends? 0. Is it defined for 0? Yes. 0 factorial is 1. So that's about the factorial. I'm sure we are all clear on this. So let's go to the fundamental principles of counting. Let me illustrate the way the school does it. Let me not try to spend time on fancying it, etc. Rather, let me just make it Let me make it straight to the point. Let me come straight to the point and illustrate this. What is product rule? What is addition rule? Right? Product rule is something like this, friends. If an activity one, if there are multiple activity, if the activity one, or if there are multiple activities, let's say I'm defining the product rule here for you. If the activity one can be done in m ways, if the activity one can be done in m ways, and you'll say the word and the activity two is done in n ways, and the activity 2 is done in n ways. If the activity 1 is done in 1 ways, the keyword here is and, my friends. The keyword is your and the activity 2 is done in n ways. So and is nothing but into. Alright, therefore both activities together can be done in m into n ways. Both activities, which means activity 1 and activity 2. And means what? Alright, intersection and, which means together. So both activities together can be completed in m cross n ways, m into n ways. I'll take an illustration to this. I hope I sufficiently helped you to recall this particular concept. Let me take a simple illustration on this. Let's say that okay, there is a station A, place A and place B are connected. Place A and place B are connected by 3 roads. Let's call the roads as R1, R2, and R3. Let's say that these are the roads. Of course, they will have some names: Mahatma Gandhi Road, Indira Gandhi Road, whatever, right? Subhash Chandra Bose Road. Likewise, all they'll have some names there, right? R1, R2, R3. Let these be the 3 roads. Let 3 roads, and then you say that okay, from B to C, from B to C, there are 2 roads. B to C, there are 2 roads. Let me call these names as roads as X and Y. Let B to C as X and Y, 2 roads. So now the point here is the person is at A. This is the start. The person is at A. And the person has to reach C. This is the end finish point. Or like this is the finish point. Like this is the finish point and this is the start point. Now on the network, these are the only roads. So therefore, how many ways a person can reach, or let's start from A and reach C. Therefore, number of routes, connection of roads is nothing but routes, right? Yeah. So how do we reach that? What is the number of ways you can do? Okay, you can go from A to C. So therefore, you would say that A to B. Or at first you go from A to B and then you proceed from B to C. This is the journey A to B, and you proceed from B to C. So A to B can be done in how many ways? 3 ways. That's what you are saying. Road 1 or road 2 or road 3. Good, 3 ways. And means what? Into. And means into. How many ways you can go from B to C? 2 roads. X and Y are the 2 roads. Therefore, you are trying to say that, hey, I can do this in 6 ways. All right, I can do this in 6 ways. Simply put, all right, what are the ways there? R1X is one route. R1Y is another route. R1Z is another route. Similarly, you would say, now R1X and R1Y are 2 routes, and then R2X, R2Y, R2Y are another 2 routes. Okay, then you say that R3X and R3Y are the third routes, right? Now that's what you mean by saying that m cross n ways, right? Another rule, addition rule. Addition rule. All right, let me take a simple example here to illustrate. If the first activity can be done in m ways, if the activity 1 can be done in m, all right, for activity 1, either I want you to do activity 1 or activity 2. Doing activity 1 or activity 2, in the sense, if the first activity can be done in m ways, or is substituted as plus, friends, or is substituted as plus. Whenever you say or, which means you have a choice, right? Or means plus, well, then n ways. Second activity can be done in n ways. Whenever you say or, well, you can kind of consider adding that particular number. Okay, let me take a simple example here as well. Let me introduce something out here. Let's do the same thing here. Okay, the person is still at A, has to go to C, but this time there is an intermediate, there is another road D, let's say. There is another station D. A to D, there are 2 routes, and D to C, there are another 2 routes, let's say. There are another 2 routes. Okay, now therefore, when the person has to go from A to C, what do you say? A, B, A to B, and then to C. Or, now you say that, okay, A, so let me complete this, let me write completely for you. A to B and B to C. A to B and B to C, or you may say that, hey, no, A to D, A to D, and you may say this, A to D and D to C. This is also fine. A to D and D to C. You might say like this, A to D and D to C. That is also fine. So now let's take a quick look at this. A to B, how many ways? We know that 3 ways. We already know that that's 3 ways. B to C, how many ways? 2 ways. That is X and Y. Okay, or means what? Plus. Or means what? Plus. Okay, A to D, how many ways? 2 ways. Let me give some names if you want. P and Q. P and Q are the names of the roads. Okay, then you may say that okay, R and S are the names of the roads. Good. And means what? Into D to C, how many ways? Two ways. It together, therefore, how many ways? Or, because you said or, you are adding friends. Whenever you are saying and, you are multiplying. Be mindful about this. All right, just be mindful about this. Therefore, you would say that 6 plus 4. Now you say that there are 10 routes. There are 10 routes you can reach from A to C. Right? There are 10 routes by which you can reach A to C. Right now, connection of roads become what? Essentially, that it becomes a road. Well, connection of roads become a route. Right? Yeah. So I hope everybody got the perspective on this. Let's understand that. Okay, simply put, what is math trying to say? Hey, you multiply and count. You add and count. That is it. You multiply and count, and you add and count. Simply put, when mathematically, technically, and means the two things, A1 and A2, these two activities, when you connect A1 and A2 by and, already you are trying to say that the activities are independent. Activities are independent. All right. Now, in other words, layman's language, they'll simply use the word called and. Okay. Or, whenever you use the word or, you are trying to suggest that the activities are dependent. The activities are dependent. Activities are dependent. Okay, I rather suggest, okay, if you could, if you have readily recalled from your high school, yeah, our teacher used to say something like this: independent, dependent. Fair enough. Even if you have not, if you have understood as much as I said about and or, that is good enough, because that's from the practical importance point of view. That is what is important to us. You really don't have to understand independent, dependent. What you got to understand is, okay, do I know the meaning of and or not? Okay, so when will I pronounce the word or, when will I use the word and between the two activities? As long as I'm clear about it, so we are sorted. Fine, let's go to some of the examples quickly. Let's go to some of the examples built on this. Very elementary examples, right? Class 7, class 8 students will solve this. Absolutely. Let's take a look. Class 8 student will easily solve this. I'm just starting there. I'm building that base at that level technically. Okay, let's take a look at the first question. How many 3-digit numbers can be formed by using the digits 1 to 6? Right? Yeah. So 3-digit number. What is the? How did your teachers teach something like this? They'll say that, okay, guys, we'll write 3 gaps like this. That's what the teacher says. Your cursor is at this particular place, first place. Your cursor is here, which means it's 3 places you need to fill. First place can be filled in how many ways? 6 ways. Well, first place can be filled in how many ways? 6 ways. Assume that you typed a number called 2. All right, now, although you had a choice of either you can type 1, 2, 3, 4, 5, 6, you would have typed a number called 2. What is the denominator I'm trying to write? 6 ways. 6 choices you have. You can press the key 1, or you can press that key 2 on your keyboard. These are the 6 active keys. Let's say which key I can press. Press any of the 6 keys. That's what I'm trying to say. Assume that you press the key 2. Fair enough. All right, that's a dummy. What I'm trying to say is a dummy. Okay. Second place can be filled in how many ways? Another 6 ways. Another 6 ways. All right, this also can be filled in another 6 ways. Why? Hey, can I type a 2 again? Why not? Why not? You can type a 2 again. Now look, what is the question asking you? How many 3-digit numbers can be formed? Simple. Hey, can I write a 2 or a 220 something? Of course, yes, you can write. There is no problem there. Right? Okay. My third number can also be filled in 6 ways. Hey, why do you say so? Can I write a 2 another again? Of course, absolutely, yes, you can write it. Is 222 a 3-digit number? Why not? It is also a 3-digit number. Therefore, first place can be filled in 6 ways, second place can be filled in 6 ways, and the third place can also be filled in 6 ways. Good. Okay, now the principle comes into play. Man, I have 3 numbers now, 6, 6 and 6. I have a 6 here, I have a 6 here, I have a 6 here. Point here is, should I add these numbers or should I multiply these numbers? Or should I multiply these numbers? Now that's the question out here, right? That's a primary question here. That's what the principle helps you. It says that, hey, should I fill the first place and the second place and the third place? You have 3 places like this. Should I fill the first place and the second place and the third place? Or should I say, no, I will fill the first place or second place or third place? Of course, the word you use is, you got to fill the first, second and third. It is not or means you have a choice. You may leave that blank as well. Hey, you can't leave it blank, isn't it? So therefore you say that, okay, I will fill the first, second as well as third and third. Therefore what you are trying to say, into is the right fit. That's all. So now your fundamental principle does not tell you write a 6 here. It does not tell you. That's your common sense. All right, that's the reason a lot of people feel stressed when they are doing a permutation combination, because the numbers are yours. What principle does is, principle simply connects the numbers, right? Principle simply connects the numbers. It won't tell you the number. So if you think a wrong number, if somebody would have thought like this, hey, first place can be filled in 6 ways, second place can be filled in 5 ways, third place can be filled in 4 ways, you get a different answer. That's it. All right, now your principle may still connect these numbers and it may say that, hey, 120 is your answer, but it is wrong. Well, but it is wrong. All right, now 216 should be your answer. 6 into 6 into 6, 216 should be your answer. If you have done this, then it is wrong. But the principal is still putting an into here, but it is putting an into between the wrong numbers. All right, between the wrong numbers. Numbers are yours. That's your logic. All principal does is it suggests you, it helps you whether you need to multiply the numbers that you have written or should you be adding the numbers that you have written. I hope that's a basic part. All right, that's a basic part of understanding the fundamental principle of counting. Great. Let's come to the second example, friends. Let's come to the second example here. Here we go with the second example. Again, 3-digit number can be formed by using the digits 0, 1, 2, 3, 4, 5, 6. Very good. The first place can be filled in 5 ways. First place can be filled in 5 ways. Why 5 ways? All right, because the first place you cannot write a 0. Write anything other than 0. Write anything other than 0. Can I write a 1 here? Oh, of course you can write a 1 here, no problem. But don't write a 0. Good. Second place can be filled in how many ways? 6 ways. Second place can be filled in 6 ways. Why? Can I write a 0 here? You can write a 0 here. Hey, can I write a 1 here? All right, no, I don't want to write a 0. Can I write a 1 here? You can write a 1 there. All right, you can write a 1 there. All right, can 111 be a number? Why not? It can be a number. Therefore, second place can be filled in 6 ways. Third place can be filled in 6 ways. Right, therefore 5 into 6 into 6. All right, that's where the 0, all right, tacit understanding. When I said that, why don't you write a 3-digit number? The first digit cannot be a 0. That won't make it a 3-digit number. The hundreds place cannot be a 0. Therefore, other than 0, you write other thing. First place can be filled in therefore 5 ways. First place is filled in 5 ways. Rest of the places are filled in 6 ways each. You got to fill all 3 places. The principal tells you that, hey, multiply these numbers there. All right, therefore you are saying that the given result is nothing but 180. This time 180 numbers can be formed. Look guys, this is called as isolation. Isolation means what? One place has no bearing on the other place, right? Which means you wrote it 2 here, you can still write it 2 here. Or just because you wrote it 2 there, it doesn't stop you from typing another 2 while writing the number, right? Unless author tells that. We'll come to that point in a while. So first let's understand the principle. What it's trying to do? It's trying to put the intos there. All right, now let's quickly wrap this up, wrap up this logic. So another 3-digit number. 3-digit number. So what did he say? Odd. You may say that, hey, shall I start here? Shall I start here? You can start anywhere that you like, because it's a technique of isolation. Isolation means what? Which place you fill first does not really matter. Can I fill it here? Yes. All right, now. So how do you understand that the given number is odd? The units place should be odd. This particular place where I'm putting an arrow, this place should be odd. If this place is an odd, which means what? I can fill it with 1, I can fill it with 3, or I can fill it with 5. I can fill it in 3 ways. What are the 3 ways here? Either you can use 1, or you can use 3, or you can use 5. You can use one of these 3 particular digits out there, because I said that how many 3-digit numbers can be formed by using the digits 0, 1, 2, 3, 4, 5 such that they are odd, right? Therefore that can be filled in 3 ways. I showed you which are the 3 digits there: 1, 3 and 5. Right, so that's about the units place. All right, so now you may say that, hey, I will directly jump to hundreds place. Jump wherever you want to jump, does not matter, because it's isolation. Isolation means what? You got to fill your hundreds place, you got to fill your tens place, you got to fill your ones place. Is there an order to it? Absolutely no order to it. Your choice. You just have to ensure that all 3 places have been considered for evaluation. All 3 places are considered. So you may say that, hey, first place can be filled in how many ways? 5 ways. First place can be filled in how many ways? Of course 5 ways. Hey, which are the 5 ways? Other than 0, fill anything. You can write 1, 2, 3, 4 and 5. Just don't write a 0 there. That's it. Fair enough. All right, now that place can be filled in 5 ways. What about the middle one? 6 ways. What about the middle one? 6 ways. You can write any of the 6 digits there. So therefore the value is nothing but 5 into 6 into 3. All right, 5 into 6 into 3, that's 18 into 5, which is nothing but 90. 90 such numbers can be formed. Fair enough. Let's write the last one, friends. Quickly, let's write the last one. Let's write the last one. I hope you are all getting the idea here. Let's write the last one quickly. All right, that kind of, all right, now with this, all right, we completed our 7th or 8th standard now. Okay, so here we go, 3-digit number. I want it to be even. You may say that, hey, this time I will fill the middle number first. Fill it, yeah, fill it 6 ways. The middle number can be filled in 6 ways. Why? No limitation. You can fill 0, 1, 2, 3, 4 and 5. You can fill anything there. All right, no, because that's a beauty of isolation. All right, I wanted you to remember that your teacher talked about isolation. That's what I want you to remember. That's the whole idea. What word your teacher gave, I don't know, but teacher would have taught about this. Hey, sometimes there is an isolation. You can fill anything, but of course in the school we fill the first place first, and then we fill this, but teacher would have clearly demonstrated saying that, hey, there is an isolation to this. You can fill any place first. Then you may say that, hey, I will fill the last place now. Fill it, yeah, fill it. Last place can be filled with 0 or 2 or 4. This can be filled in 3 ways. All right, this can be filled in three ways, any three digits, either 0 or 2 or 4. Good. Yeah, what about the first place? Can be filled in 5 ways. Why? Oh, except the 0. 0 cannot be used except 0. Use any of the remaining 5 digits. Well, it is also therefore 90 numbers. There are 90 such numbers, right? Yeah. So therefore you got a orientation to this. What I tried to do this here, the last 10 minutes is I taught you, just quickly spoke about isolation and the fundamental principle of counting, how that into is going to be used. Right. Okay. Now let's come to the second part, connection. And there is another opposite technique your teacher would have spoken. Probably names could be different, friends. The name teacher could have given could be pretty different. In the high school, or different syllabus, different books might call it as a different name, or teacher might have given a different name. Please recall all it, whichever the way your teacher used the word there. I generally use the word as a connection. There is a connection between the digits, the connection between the places there. Okay, let's take a look here. Let's take a look here. How many three-digit numbers having distinct digit? Now I'm introducing a word. This wasn't there so far. All right, distinct digits can be formed, or it can be formed by using the digits 1, 2, 3, 4, 5, and 6. It's a pretty similar question that we did in the beginning. So, but I am introducing this word distinct digit. This time the repetition is not allowed. In the sense, when I'm writing my three-digit number, first place can be filled, or first place can be filled in 6 ways. Let's assume that you used a 2. You had a choice of 6 digits on your keyboard. You had a choice of 6 digits on your keyboard. I'll assume that you filled a 2 there. You filled a 2. But the point is, once you used a 2, the 2 is removed. 2 is deactivated. Now you can't use the digit 2 once again. Good. So if I can't use a 2, second place can be filled in how many ways? 5 ways. All right, now because 5 ways. Now use a dummy. Out of 5 ways, assume that you used a 1. You used a 1. Just a dummy for illustration purpose. You used a 1. So therefore 1 is also ruled out. Last place can be filled in how many ways? 4 ways. You got to fill the hundreds place. You got to fill the tens place. You got to fill the ones place. That's when you get a 3-digit number. Therefore you would say that, okay, the 3-digit numbers that can be formed are nothing but 120. There are 120 3-digit numbers that can be formed by using the digits 1, 2, 3, 4, 5, and 6, by using the first 6 natural numbers. Good. Let's take a look at the second one, friends. Let's take a look at the second one. Okay, quickly reflect on this thought. Take your pens, pull out your book, take your pen. Why don't you all now quickly put this to perspective? Write down the numbers. Right, very good. As you rightly understood, 0 cannot come in the first place. 0 cannot come in the first place. Therefore, the first place can be filled in 5 ways. First place can be filled in 5 ways. We all need to start here. We all need to start here in this particular problem, right? Yeah, first place cannot be filled with a 0. Therefore, it can be filled with any of the remaining 5 digits. That is 1, 2, 3, 4, 5. Let's assume you filled a 3. Let's assume you filled a 3. Dummy, you should have filled something there. Assume that you filled a 3. Fair. All right, now so assume that you filled a 3. Which means what? 3 is inactive now. 3 is inactive. Second place can be filled in how many ways? 5 ways. Hey, why 5 ways? You can fill 0 now. You can fill 1. You can fill 2. You can fill 4. And you can fill 5. Now this can be filled in 5 ways. Assume that you filled a 0. No problem. Therefore 0 is out. You can fill anything there. All right, now you filled a 0. Great. Last place can be filled in how many ways? Any of the remaining 4 ways. Now you can fill this with 1, or you can fill this with 2, 4, or 5. Any of the remaining 4 ways. So therefore you say that, okay, number of 3-digit numbers that can be formed by using the given digits is nothing but 100. Right now, so here we all have to start with this particular place here. All right, we all need to start with this particular place. When there is a connection, it's important where to start the problem. It is very, very important to understand where did I start my problem when there is a connection. Earlier I talked about isolation. Where do you start the problem? You had a choice. When it is a connection, you don't have a choice. I'll come to that point. Suddenly you may be wondering, you don't have a choice? Yes, your teacher said sometimes. They said that, hey, you don't have a choice. Rahul, you don't have a choice. Something like that. Okay, Rahul is just an example. Right, here we go. Let's take a look at the first question here on the top. How many 3-digit numbers having distinct digits can be formed by using the digits 0, 1, 2, 3, 4, and 5 such that they are odd? Now look at this. They are odd. All right, such that they are going to be odd. Now listen to me, friends. Everybody listen to me carefully. All right, listen to me. So if it is odd, look anytime. All right, now so there are 2 types of limitation. The first one, all right, now first one is implicit restriction. I will call it as implicit restriction. Now here it is an explicit restriction. Here there is no restriction. I don't know what words your teachers have used, but they would have used similarly some kind of words like this. All right, whenever the things are connected. Basically, what is this example? Basically, it's an example on connections. All right, now either one of them is the isolation technique and the technique of connection. Right, now when the digits are connected, so they would have said that, hey, segregate the digits, in the sense they said that, hey, at times there will be explicit restriction, there would be implicit restriction, there would be no restriction. All right, now these are the three words they would have used, and they would have said that, hey, first you got to tackle explicit restriction. That's the order. First, if there is any explicit restriction, you got to tackle that. After that, you got to go for implicit restriction, and then you should go for no restriction. All right, that is the order. That is the order in which, like a BODMAS. Right, if you are doing a math, if there are too many symbols out there, what do? All right, you always do all right BODMAS. You will first understand the brackets, you will resolve the brackets, you open up the brackets, right, and then you will go for off, then you go for division. Likewise, your explicit restriction, implicit restriction, no restriction, something like that. Okay, fine. Let me come to this point of explicit restriction here. What is explicit restriction? Odd. Author said that, hey, make it odd. Make it odd means what? Ensure that the unit digit ends in 1, 3, 5, 7, 9, whatever. These are the kind of digits the unit digit should end in. All right, that is what you mean by explicit restriction, which means author was vocal about it. He said that make it odd. Now, so what was author was not vocal about? Implicit or a tacit understanding, implicit understanding, which means I don't have to tell you, you kind of understand it. All right, sometimes your parents or somebody don't have to tell you, you will understand it. All right, based on the context, you understand what they meant, right? Similarly, that's implicit. Without saying, you kind of understand, right? What is implicit condition? Because author simply said 3-digit number, you know that 0 cannot come here. 0 cannot come here. That's an implicit understanding. Implicit means I don't have to tell you saying that, hey, 0 should not come in the first place. It's understood. It's understood. Okay, no restriction means what? Anything can come here. All right, no restriction means what? Can I write a 0? You can write. Can you write 1 here? You can write. Can I write a 2 here? You can write anything. All right, but then explicit restriction, can I write 0 here? No, you can't write. Hey, can I write 2 here? No, you can't write. Explicit limitation. What is that? The unit digit should be odd. Okay, I sufficiently helped you to recall now. I guess I sufficiently helped you to recall. So now these are the things. These are the words your teacher would have used in the high school. Whenever you learned this particular subject based on the boards that you studied, right? Yeah. So one, there are connections. When you talk about the connections, we are talking about connections. So we name the places. That is, there is an explicit restriction, implicit restriction, and no restriction. Let's take a look at this, friends. Let's take a look at this particular question now. Therefore, keeping this in mind, we know that, hey, this is an explicit restriction. Why? Because I want this to be odd. I want this to be odd. All right, that's an explicit restriction because I want this to be odd. All right, now here it is an implicit restriction because I don't want a 0 here. I don't want the 0 here. This is no restriction because anything is welcome. All right, anything is welcome. So first hierarchy, where I need to go? Explicit restriction. What is it trying to say? Hey, you can write either 1 here or 3 here or 5 here. Now 1 here is possible, 3 is possible, 5 is possible. You can say that is 7 also. No, because author has limited the digits here 0 to 5. Therefore 1 or 3 or 5. This place can be filled in 3 ways. Perfect. All right, this case can be filled in 3 ways. Let's assume that you filled a 5. You filled a 5. Fair enough, you filled a 5. You filled a 5. 5 is no more available because we are talking about distinct digits. 5 is no more available. Perfect. All at 3 places can be filled. Come back to the initial place, friends. Come back to the first place. Now this place can be filled in 5. This place can be filled in 4 ways. You may wonder, hey, why 4 ways? Now this can be filled with 0. This can be filled with 0 now. Or it can be filled with, it can be filled with 1. Sorry, it cannot be filled with 0. It can be filled with 1, 2, 3, 4, because 5 has been already consumed and 0 cannot be used. Therefore, what you are trying to say, this can be filled in 4 ways. Let's assume that you used a 1 here. You used a 1 here. It's a dummy, friends. You used a 1 here. All right, 1 is also out of contention. All right, therefore, how many ways the middle place can be filled? It can be filled in 4 ways. Any of the 4 ways are fine. In sense, you can either use 0, 2, 3, or 4. Right? So therefore, you say that what I need to do, you got to fill the hundreds place, you got to fill the tens place, and you got to fill the units place. Right? Therefore, you are saying that there are 48 such numbers. There are 48 numbers of this particular category where all right, the number is odd and the digits are distinct. All right, now so this is the category by considering the digit 0 to 5. Right, 0 to 5. So that's about this particular question. I hope I sufficiently helped you to recall these important words: explicit restriction, implicit restriction, no restriction, connections, right, isolations. Now these are the 5 words I wanted to talk about. So I don't know, your teachers might have used different words for this, does not matter, but then I kind of connected with a similar meaning with respect to these 5 words. So now here we go. Let's take a look at second question here. Second question, let's take a look at this question. How many 3-digit numbers having distinct digits can be formed by using the digits 0, 1, 2, 3, 4, 5 such that they are even. So they are even means what? All it now. So if they are even, we are trying to say that okay, because you are saying even, there is an explicit restriction. There is an explicit restriction here. There is an implicit restriction here. What is implicit restriction? Because 0 cannot come in the first place. 0 cannot come in the first place, and there is no restriction here. Now listen to me carefully. I want you to listen to this very carefully. So last place can be filled in because you have to make it even. Therefore, last place can be filled with either 0 or 2 or 4. Perfect. Therefore, you will say that 3 ways. Very good. No problem. No problem. But the point here is, now listen carefully. If you say that, hey, I used a 4 here. Good. If you used a 4 here, 0 cannot come here. Therefore, you are saying that no 0, no 4. All right. When you are coming to the implicit restriction, this place, because 4 you have used, and then you are saying that okay, now I'll come to the implicit restriction place, because hierarchy, after explicit restriction, you must make a pit stop at implicit restriction. Therefore, you arrive there, implicit restriction. So 4 has been already used. Okay. Therefore, 4 has been used. 0 cannot be used because 0 cannot be used here. If 0 cannot be used, how many other digits can be used? Remaining 4 digits can be used. Good. Now keep this in mind, friends. Keep this in mind. One of you may say that no, I will use 0 here. All right, no, so therefore you wrote 3 here and you wrote 4 here. Now, all right, now when you wrote 3 there, all right, now keep this in mind. Just keep this point in mind. So you say that okay, I use a 0 here. Absolutely no problem. If you use 0 there, no problem. This is still 3 ways, because either you can use 0, 2, or 4. But the point here is, now you will say, okay, I already used a 0. I already used a 0. Now implicit restriction, when I come to this particular place, I can fill it in 5 ways. I can fill it in 5 ways. In the sense, I can write 1 here, 2 here, 3 here, 4 here, or 5 here. So now earlier you said that man, it is 4 and then 3 and then 4. Now you are saying that man, it is 3 and then 5. There is a problem. All right, what is that problem? So because implicit restriction is because of what? Implicit restriction is because of 0. Implicit restriction is because of what? All right, implicit restriction is because of 0 technically. So therefore, if the 0 has been already used in explicit restriction, now where is the question of implicit restriction? All right, now therefore you make 2 cases. Remember, whenever 0 is used in the explicit restriction place, whenever 0 is used, where 0 is used in explicit restriction place, we'll make 2 cases. When 0 can be used, or not definitely used, when 0 can be used in explicit restriction place, we make 2 cases. Let me illustrate this. So what are the 2 cases that you do here? All right, the case 1, 0 used in explicit restriction place. That's one possibility. Or 0 not used, where 0 not used in explicit restriction place. You make the cases right at that level, the beginning of the problem. All right, 0 being used in explicit restricted place, or 0 not used in explicit restriction place. So okay, what is the decision that you made? 0 is used in explicit restriction place, then you use it. You don't have a choice. 0, one way. Right, one way, because you said that 0, I'm going to use it in explicit restricted area. Absolutely, because you wanted that to be even, and you said that 0, I want to use it. Use it, please use it. Please go ahead and use it. Therefore, you are finished with your 0. Done. 0 is done. So now we are saying that okay, what about this no restriction and no restriction? Because 0 was what causing the implicit restriction. Is there an implicit restriction now? No, because in the explicit restriction you used a 0. What about the remaining places? Therefore, 5 into 4. Well, at 5 into 4. First place can be filled in 5 ways. The remaining place can be filled in 4 ways, because 0 has been already used in explicitly restricted area. Very good. All right, yeah. This is one side of the answer. Or now look at this, guys. This is where the fundamental principle is coming. You say that 0 used in explicitly restricted area, or 0 not used. You will not use and 0 is used. It cannot be simultaneously used, isn't it? Therefore, you say or means what? Plus. Okay, now another case, second case. What is the second case? 0 not used in explicit restricted area, yet it should be even. So what are the digits that you use? 2 or 4? 2 ways. All right, 2 ways, 2 or 4. Now, but you don't use both 2 and 4 simultaneously. One of them you would have used. Perfect. One of them you might have used. Let's assume that you used a 4. You used a 4. So when you come to the implicit restriction area, 0 still cannot be used, because you just used a 4 here. You used a 4 between the 2 digits. So therefore, no 0, no 4. 4 ways. No 0, because no 0 and no 4. No 0 and no 4. Therefore, 4 ways. Good. So let's assume that you used a 5. Assume that you used a 5. Fair enough. Now, therefore, you are trying to say that 4 and 5 are used. Hey, what about the middle one now? Middle one, you can use either 0 or 1 or 2 or 3. So therefore, that also can be used in 4 ways. Therefore, you are trying to say, okay, from here, all right, from here, I can write 20 numbers. And then from here, All right, and then from here I can write, all right, now 32. Now I can write 32 numbers. I can write 32 numbers. Totally, I can have 52 such numbers. Totally, I can have 52 such numbers. 52 of them are even, 48 of them are odd. 48 them are odd. Earlier 48 were odd and 52 were even. I hope all of you understood this, how I'm using this or and part, because I did one example on this or as well, and the importance of zero as well, right? Importance of zero as well. Here we go, friends. Now this summarizes, this completes my 5 points here. All right, one. So what is that isolation, the technique of isolation, and the technique of connection? In the sense, the concept of isolation, concept of connection, because sometimes the places digits are connected, sometimes they are isolated, right? Connection, isolation. When it comes to the connection, we have explicit restriction, implicit restriction, no restriction. When to look at them, all these points should be lucid, bit should be clear by now. So let's go here, the cat example. The second one is a cat question. Nevertheless, I want you to do both the questions, 2 minutes, 2 to 3 minutes. I want you to think about both the questions on the screen. Think about them. Pull out your copy. I want all of you to pull out your copy and start working alongside me. I give a little more time because the second one, the cat question, would definitely take some time out there. Okay, let's do this together. Everybody, let's do this together. No worries, let's do this together here. Let's do it together. Okay, so this is what this question is talking about. So in how many ways? First one is isolation. Basically, first one is the technique of isolation, right? Isolation and connection. Isolation and connection, right? Isolation and connection. What is numbers in decimal system? That's which means 0 to 9 are the digits. Decimal system is what? 0 to 9 are the digits. Can be formed such that they are divisible by 4. What is the divisibility rule for 4? Last 2 digits should be divisible. Last 2 digits should be divisible. See, like just like whenever you said that earlier, hey, I want the number to be even, I want number to be odd. What is that? Explicit restriction. Explicit restriction on units place, explicit restriction on units digit, explicit restriction on units digit. Basically you're talking about units digit. Hey, can there be more than one digit? Why not? Why not? Explicit restriction can be on more than one digits as well. That's the point I'm trying to make here. Okay, therefore explicit restriction should be on both of these particular digits. Yes, that's right. And then what about the remaining two? Isolation. So you may say that, hey, what about this place? This place can be filled with anything from 1 to 9 ways. Anything from 1 to 9 except 0, because you can't write a 0 because I'm looking for a 4-digit number here. All right, the middle one can be filled in 10 ways. Anything from 0 to 9, anything from 0 to 9 is welcome. You can repeat the digit as well, because I never talked about distinct digits in the first question, friends. I didn't talk about distinct digits in the first question. So therefore 10 ways. Now what about the last two places? Last two places can be filled in 25 ways. Last two places can be filled in 25 ways. Let me tell you this. All right, now last two places, let me illustrate. Now this is what you had. Last two places. Last two places can be 00. Well, last two places can be 04. Last two places can be 08. Last two places can be 12. All the multiples of 4s, my friend, right? Likewise, up to where? Up to 96. This is 4 1 time, 4 2 time, 4 3 time. Like this, this is 4 24 times. See, look, the first one, 00 is what? 4 into 0. Now this is what 4 into 1, that is 4. This is what 4 into 2. This is what 4 into 3. Like this. This is what 4 into 24, which is 96. All right. Therefore, 25 cases. 0th case, first case, second case, up to 24 cases. Therefore, there are 25 cases. That's a required answer. All right. That is therefore that is nothing but the required answer here. Right. That's a required answer. 9 into 10 into 25 is the required answer. 25 into 5. All right, which is nothing but 225. Therefore, you say that my answer is nothing but 2250. All right, 2250, 25 into 9, 225, and then there is a 0 there, therefore 2250. Simple one. I hope all of you got this. So basically I wanted you to understand that okay, there is a technique of isolation. When we talk about all right now the restricted areas, all right, limited areas, that can be one digit at a time or it can be more than one digit at a time, does not matter. All right, therefore there is an explicitly restricted area, it can be one digit or more than one digit, doesn't matter. Okay, now let's come to the second point. All right, now how the second one is different there, how the second one is different, let's understand this. Again, you'll make two cases. Again, you would make two cases. What is that? 0 used in explicitly restricted area. 0 used in explicitly restricted area. 0 not used in explicitly restricted area. These are the two cases. Firstly, on the face of it, now listen to me carefully. Listen to me carefully. Even on the face of it, last two are explicitly restricted area. Both of them together are explicitly restricted area. Earlier, we said that these last two places can be filled in 25 ways. We said that these two can be filled in 25 ways. So the point here is when I'm talking about the distinct digits, you can't fill it in 25 ways, isn't it? Yeah, because 0, 0 cannot be used. 0, 0 cannot be used, right? That cannot be used. Then I said that we had 0, 4, 0, 8, 1, 2, all that is fine. So in between comes 44, which cannot be used. So in between, while you're writing all these numbers, well, now while you're writing 0, 4, 0, 8, 12, dot, 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 somewhere in between there is a number 44 that has to be eliminated. And somewhere in between you would have got 88, which should be eliminated. Before you got this 96, there was an 88 as well. Therefore, what is that you are trying to say? Three numbers are eliminated. So you earlier said that there are 25 ways. Out of these 25 ways, 3 are gone. Therefore, there are 22 ways. Therefore, there are 22 ways. Again, between these two 20 or 22 ways. Now listen, well, it's 0 used in the restricted area. You have one place where 0 is being used in the restricted area. You also have the numbers where 0 is not used in the restricted area. Again, you have two types of numbers. That's what you are coming to here. What is that? 0 used, case 1. 0 used in explicitly restricted area, or 0 not used, that is 0 not used in explicitly restricted area. These are the two cases: 0 used in explicitly restricted area or 0 not used in explicitly restricted area, isn't it? These are the two cases I'm talking about. Okay, let's go to the first case, friends. Let's go to first case. Let's go to first case. Now this is the explicitly restricted area. If 0 has been already used, all right, then there is no restriction here because 0 is already used in the explicitly restricted area. Why do you say that the first place becomes implicitly restricted? It won't become implicitly restricted because 0 is already consumed. Therefore, no restriction, no restriction. Perfect. All right, now what is the second one here? What is the second point that you are trying to say? 0 not used in explicitly restricted area. Then this becomes implicit restriction and this becomes no restriction. This is explicit restriction. Right, this is explicit restriction. Okay, let me give an example to you. Hey, what is this 0 used in the explicitly restricted area? 04 is an example. The number 04 is an example. But 04 is one example. Hey, how many other numbers are there? 04 is there. 08 is there. There is a 20, 40, 60, 80. All right, therefore you are saying that, man, there are 6 such numbers. This is the list of 6 numbers I'm giving you. This is the list of 6 numbers I'm giving you. 04 is an example. 04 is an example. Therefore, if you have all 10 digits, 0, 1, 2, 3, 4, 5, like this up to 9, if you have all these 10 digits, 0 is already used. 4 is already used. Good. So therefore, how many more digits are left? 8 digits are left. I can write that 8 there. How many more digits are left for the next place? 7 more digits are left because 0 is already used. Therefore, 8 into 7 into 6. That's a point you are trying to make. Very good. All right, that is one side of the story. That's one side of the story. Plus implicitly restricted area. So now this here, now look at this explicit restriction, 0 not used. What can be an example? 12 can be an example. 12 can be an example. But the point is, how many such numbers are there? How many such numbers are there? Simple, friends, number of such numbers we're talking about. When you talk about number of such numbers, out of these 22 ways, all right, 0 is used, 0 not used. 0 not used. These are the two cases. How many cases are there in which 0 is used in the explicitly restricted area? 6. All right, that's what you wrote here, 6. Therefore, in how many places 0 is not used in the explicitly restricted area? 22 minus 6, because total was 22. 22 minus 6, all right, which is nothing but 16. Right, there are 16 such cases. All right, 16 such cases. That's what you write here, 16 such cases. 12 is an example, my friend. So therefore you have the digit 0, 1, 2, 3, 4, etc. Right now, so after 0, 1, 2. So now what you are trying to say, 1 is used and 2 is used. 1 is used and 2 is used. But when it comes here, 0 also cannot be used, 1 also cannot be used, and 2 also cannot be used. Therefore, this can be used in 7 ways. Assume that 3 is used. Assume that 3 is used. Now, therefore, when you come to this no restricted area, 0, 1, and 1, sorry, 1, 2, 3 cannot be used. Therefore, it can be used in remaining 7 ways. This place can be used in remaining 7 ways. I hope all of you got this idea here. And in between, what sign I have? Plus sign I have. Therefore, what is the reuse? What is the answer to this? 8 into 7 into 6 plus 7 into 7 into 16 plus 7 into 7 into 16, right, which becomes the answer for the given question. I hope all of you got this, how I am using the explicitly restricted area, implicitly restricted area, no restricted area. If something is not clear, friends, after the lecture, please go back and listen to this particular part of the video once again. Let's listen to this once again, because there is nothing new I taught here. Now to do this question, I gave that kind of background to it, right? I gave a background so that like you are capable of doing this particular kind of questions. So here we go. Let's proceed with our lecture. Let's proceed with our lecture. Same questions, same questions. Now this time I'm talking about the words. All right, I spoke about numbers so far. All right, numbers so far. I'm talking about the words here. I'm talking about the words here. Why don't you try these two questions quickly? So why don't you try these two questions quickly here? Why don't you try them? Yeah, good. Good. Both the questions are done. Very good. Yeah. How many four-letter words can be formed by using four of the letters of the word number? All right. Now all are distinct. N is different. Let number. N is different. U is different. M is different. B is different. E is different. R is different. Say how many distinct letters I have? 6 letters I have. Four-letter word has to be formed. Four-letter word has to be formed. First place can be filled in 6 ways. Second place can be filled in 5 ways. Fourth, next place can be filled in 4 ways. Next place can be filled in 3 ways. That's your answer. 6 into 5 into 4 into 3. That's your answer. That's it. So beat words. My point with this particular question is what? Hey, don't panic. Beat numbers or beat letters. It works the same. Well, it beat numbers, beat letters, it works the same. The objects can keep changing. So far, I had the number digits. Now I have the letters, alphabets. So objects kept changing, but the concept won't change. Concept won't change. To form a four-letter word, meaningful or meaningless, whatever be it, to form a four-letter word, you got to fill the first place, second, third, and fourth. There are 4 places that you need to fill to form a four-letter word. Next one, how many 6-letter words can be formed by using all the letters, of the word number? 6 factorial, because if you are writing 6, well, you will say that first place can be filled in 6 ways, 5 ways, 4, 3, 2 into 1, which becomes n factorial, which means if there are 6 digits, 6 numbers, it will be 6 factorial. If there are 4 digit, 4 digit, if there are 4 digits, 4 places and 4 different letters, 4 factorial. Therefore, n things can go in n places in n factorial, but that should be n distinct things. That's a point here. My point here is that you can write 6 things in 6 factorial provided all these 6 things are distinct, n distinct things. If n distinct, only then we can write that n factorial. N distinct things can be arranged in n factorial. N distinct things, by taking all of them, can be arranged in n factorial. I hope all it now from here. There is another high school concept, very popular one. Please quickly think about this. Write the answer to yourself. Please write the answer to yourself, both the questions. I'm sure you can recall from your high school. I'm sure you can recall. Please recall and plug this, finish it. Good, very good. Right, yeah. So here, all right, now here you're using this particular concept called, all right, given n things. All right, let me put it to perspective here. Given n things. Given n things. right, or given n things, may give n digits, n alphabets, or a combination of them, does not matter. Given n things, not all different, right? Not all are different. Not all are different. Not all different. Basically, they are all not all are different. Then how they are? P things are alike. P things are alike. Say that they are of the type 1. Q things are alike. Say they are of type 2. Rest are different. Rest are different. It may not be only P and Q. You may say that a dot 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 whatever dot dot dot. Rest are different. All right, rest are different. This is the composition. All right, then all right, arrangement, total arrangements. I'm talking about total arrangements because the formation of word is arrangement, my friends. Total arrangements by taking all n things. Total arrangements by taking all n things. Total arrangements by taking all n things. Already is given by, already you would have understood, is given by n factorial divided by p factorial, q factorial, dot dot dot, etc. So whatever the number of groups that can be formed. Well, that's what precisely the concept that you would have used. I'm hoping that okay, you kind of recall this particular concept. If not, all right, now try and recall now. So how many? Let's go back to this question. So words should be all of them. All right, now so 1, 2, 3, 4, 5. How many 5-letter words can be formed by using all the letters of the word floor? So you would say that okay, there are 5 letters, no doubt. There are 5 letters, but these two O's are same. All right, these two O's are same. Therefore, you have said that answer is 5 factorial. But because these two O's are same, this is the P things. P is nothing but two things are alike. You divide this by 2 factorial. Therefore, you divide this by 2 factorial. This is the answer. Total number of 5-letter words that can be formed are 5 factorial divided by 2 factorial. 5 factorial is 120. 120 divided by 2, which is 60. All right, which is 60. Fair enough. All right, let me quickly help to understand here. See, we already have one word called as floor. We already have one word called as floor. If I interchange these two, will I get another word? No, it is the same word. By interchanging the positions of zeros, you will not get positions of O's. You will not get. Assume that we have another word called FOLOR. All right, now by interchanging these two O's, will I get a different one? No. That's what you mean by 5 factorial. In the sense, you said that, okay, let me take this O1 and O2 here. All right, let me take them as O1 and O2. If I just write a subscript O1 and O2, if I interchange, will it be considered as a different word? Yes, because O1 and O2 are different from two O's. All right, therefore, you will write. So that's what you mean by 5 factorial first. But then you said that, hey, I will divide them by 2 factorial because technically there is nothing called as O1 and O2. O is O. Therefore, you said that, okay, I will divide by 2 factorial. That was the kind of a concept your teachers tried to explain, which is very right. That is what it means. All right, that is what it means. All right, that is the whole thing out there. All right, that is the whole thing. Therefore, you are dividing by 2 factorial. In a sense, first you are thinking them to be different. When there are two O's, first you are thinking them to be different, 1 and 2, and then you created 5 factorial because now you saw 5 distinct letters, and then you've called it as 5 factorial. But you realized, hey, there is nothing called as O1 and O2. O is O. Therefore, you divided this by 2 factorial because I had 2 letters which are identical. Therefore, I divided this by 2 factorial. What if there were 3 letters which were identical? I will divide by 3 factorial. That much of multiple counting will be there. Therefore, I will get rid of them. I will get rid of them. First, I assume them to be different. And then I say that, hey, bet they are not different. Therefore, I divide by something or divide by something to eliminate them. Okay, some of you may be thinking, why not subtracting them to eliminate? Why on earth I'm dividing them to eliminate? Shouldn't it be subtraction? No, because in the fundamental principle of counting, whenever you're trying to fill the gaps, what is the sign you are using there? Well, A ways, into B ways, into C ways, into D ways, into F ways. That's what you are using here, right? You are multiplying the number of ways, A number of ways for the first place, B number of place for the first place. Hey, what is opposite of multiplication, friends? Division. That's what I'm doing. If you have added the numbers, then I will subtract, because opposite of addition is subtraction. But you are multiplying here already. While counting these words, you are multiplying. Hey, what is the opposite of multiplication? Division. That's it. Mathematically, we got to do the opposite action. We got to perform the opposite action to get rid of things. Right? Yeah, because I was multiplying, I'm dividing. That's a simple way, guys. That's a simple way to understand. All right, let's go to the next one. Let's kill this. Let's go to the next one. How many 9-letter words can be formed by using all the letters of the word institute? All right, so what is my composition here? Let's understand. I, N, S, T, I, T, U, T, E. All right, now this is my word institute, right? This is my word institute. So what is happening in this word institute? Of course, all right, now how many 9 letters are there? 9 letters are there. 9 letters are there. Out of 9 letters, I is coming t 2 times. That is what you mean by p palette p alert. Now that's what you mean by p factorial, which means I is coming 2 times. Hey, what about t friends? T is alert. This is coming 3 times. That is what I called it as q. Alright, this is coming 3 times. Assuming all 9 letters are different, you would have written your answer as 9 factorial. Assuming all 9 different, you would have written 9 factorial. But these two i's is I. So in the mind, you would have taken it as I1 and I2. Hey, there is nothing called as I1 and I2. I is an I. Therefore, all right, now, so what you are trying to say, divide by 2 factorial. In your mind, while counting 9 factorial, you took it as T1, T2, T3. But there is nothing called as T1, T2, T3. T is a T. All right, therefore, you say that, hey, therefore, I'll divide this by 3 factorial, which becomes my answer, right? 9 factorial by 2 factorial, 3 factorial would be the answer. Okay, so far, if you think that, okay, in the last 1 hour, what did we do? Well, technically, precisely about 50-55 minutes. If you think that, what did we do? We did arrangements. Well, if anybody has to clearly understand what did we do using this fundamental principle of counting, formation of numbers is nothing but arrangement of digits. Formation of word is nothing but arrangement of letters. So therefore, so far what I taught you is arrangements. I was talking about arrangement. Technical word for arrangement is what we mean by permutation. I wasn't wasting any bit of time, my friends. I was teaching you permutations. All right, I was teaching you permutations. I wasn't wasting any bit of time. Right, entire last 50 minutes, I was talking about permutations. Right, this is what we were trying to do out there. So, okay, is that what? Yes, permutation is a technical word. Right, in a layman's language, it is nothing but an arrangement. Similarly, you would have come across this particular word called as combination. Come across this particular word called as combination. Layman's language, selection. Well, layman's language of this is simply nothing but selection. I was teaching you arrangement. In fact, I taught you beyond NPR. All right, now one of the things people recall the moment I talk about permutation or the word arrangement, whichever way that you call it, or it be it permutation or arrangement, people immediately recall NPR. Friends, I spoke beyond NPR. NPR is nothing. Well, NPR is nothing. It is just a symbol. Let me prove that point to you. I was talking much beyond NPR. Much beyond NPR. Let me come to this point. So let me take this fresh page to illustrate this particular point. Now listen to me carefully. If I have the digits 1 to 9, 1, 2, 3, 4 up to 9, let's say I have 9 digits out here. If I have the digits 1 to 9, if I ask a question that, hey, how many 3-digit numbers can be formed, or how many 3-digit numbers with distinct digits can be found by using these particular digits? What is distinct, guys? Distinct. How many 3-digit numbers with distinct digits can be formed by using these 9 digits here? So you would say that, okay, the first place can be filled in 9 ways, second place 8 ways, next place 7 ways, 9, 8, 7, right? That's what you are calling it here. Now I'm saying that, okay, to this, now this is my answer. To this, I will multiply by 6 factorial, divide by 6 factorial. Why? Just to prove a point to you. I was doing the same stuff, what you guys were doing. 9 into 8 into 7 into, what did I do? I multiplied and divided by 6 factorial. So what is the numerator there for? What is this numerator has become there for this whole stuff? 9 into 8 into 7 into 6 factorial is nothing but 9 factorial. What is the denominator, friend? 6 factorial. Is it same as my answer 9 into 8 into 7? Of course yes. It's pretty much similar. Same thing. Now this 9 factorial, 6 factorial, this is only called as 9p3. In your words, this is called as 9p3. That's nothing but a number of 3-digit numbers. How many 3-digit numbers with distinct digits can be formed by using the first 9 digits, by using the digits 1 to 9, how many 3-digit numbers with the distinct digits can be formed? This is your answer here. So you would have said that, okay, this is nothing but NPR. You're trying to call it as NPR here. Yeah, what is NPR, friends? NPR is nothing but now number of ways of selecting or number of ways of arranging or things out of n different things. It's very important. These n things should be different. If they are not different, it's not going to work. Number of ways of arranging or things out of n different things. I hope all of you remember from your high school, this can be written as n factorial divided by n minus r factorial. So therefore, when you look at this question, how many 3-digit numbers can be formed by using the digits 1 to 9, and the digits have to be distinct? Your answer is nothing but 9p3. Therefore, your answer is nothing but 9p3. If you're able to recall, hey, no, I'm not recalling that 9p3. Don't worry. You already know what to do. Just calculate 9 into 8 into 7. That's also fine. Now look at this. If I bring a 0 here into this question, if I bring a 0 here, your NPR will not understand this. NPR will not understand a 0. It says that, hey, directly you can't do this. You have to come back and subtract a case. Forget it. Even if I say that, okay, how many 3-digit numbers can be formed? If I omit the word distinct. My answer is 9 into 9 into 9. Without this, your NPR will not understand that what is this 9 into 9 into 9. NPR does not understand. Technically, what I'm trying to say is, hey, you know that, okay, NPR, already you know NPR is n factorial by n minus r factorial. In the last 45, in the last 50 minutes, I was talking much beyond NPR. NPR is just one part of it. But nevertheless, let's not ignore that fellow. Let us not ignore NPR and NCR. Let me spend some time on this now. Let me come back to that. Let me come back to that, maybe spend about 15-20 minutes on it. Very, very important. So now I'm going to also deal with some of the CAT questions based on that. Sometimes the NPR, NCR is so very important, although it is elementary. Hey, can I consider it okay? Can I blush it off? Of course not. Of course not. You got to take that fellow seriously. You got to take that fellow seriously. Let me tell you that point, what I'm trying to say. Let me give you that point. Okay, here we go, friends. Here we go. So first of all, when do I use NPR and NCR? Let's be very clear about that. You use NPR and NCR. You use NPR and NCR only when these n things are different. Otherwise, don't try to use it. It's a very elementary tool. Of course, it's an important tool. I'm not saying that, okay, it is not important. It is an important tool, but at the same time, remember, it's a far more elementary tool. It cannot work wonders for you. It's a far more elementary tool. It works only if given n things are different. If the given n things are not different, of course, in our exams, we are going to get some stuff which are not going to be different. So therefore, already it doesn't work. NPR and NCR works only when they are different. Okay. By now, you would be clear that NPR is nothing but n factorial divided by n minus r factorial. Very good. All right. Now that's your NPR. Tell me, guys, what is NCR? Tell me what is NCR? What is NCR? Yeah, that's right. Okay, therefore NCR is nothing but n factorial divided by n minus r factorial. Then you are adding this bit to it. Well, this bit to it, r factorial. Hey, simply put, remember this relationship, guys. Remember this relationship. What is the relationship between these two things? It's something like this. NPR is equal to, so whenever the things are distinct, I'm talking this relationship. NPR is equal to NCR into r factorial. All right, NPR is equal to NCR into R factorial. In the sense, if you take these words, and if you substitute, what is NPR? You can substitute this for NPR. Hey, what is NCR? You can substitute this for NCR. Into R factorial, when you do, you get that stuff. I will tell you what I meant. Total number of arrangements. Total number of arrangements. That's number arrangement of R things out of n different things. Arrangement of R things out of n different things is nothing but selections first. All right, selections first. That's a very fundamental way. Selections first. First, why don't you select them? Assume that you wanted to decorate. You wanted to decorate a particular room. All right, by using 5 different bulbs, 5 different colored bulbs. You went to the shop. Right? You don't bring the whole shop your home, right? Rather, what do you do? Get the 5 different colored bulbs because you have 5 sockets. Already you have 5 sockets, and you want to decorate by using those 5 different colored bulbs. No, which bulb should be placed where? That we will decide later. But you decided to have 5 different colored bulbs. You go to the shop, figure out how many different colors are there, figure out which colors you want, how many bright you want, how many light you want, right? Therefore, what did you do? You selected them first. You wanted 5 colors. You went there and you selected those 5 colors. After that, what you do? You arrange all 5 colors. Arrange all selected. Arrange the selected ones. Arrange the selected ones. Okay, how many did you select? R things you selected. Arrange all R things. Arrange all the R things, which means what? Okay, you went to the shop. In the shop, you found that 8 different colored bulbs are there. So, but you wanted only 5 of them. Therefore, what you are trying to say? 8P5, because you have to come back and put those bulbs in the sockets and arrange them. 8P5 is nothing but 8C5. First, you select those 5 bulbs. Once you come back home, please put them in the sockets in 5 factorial ways. There are sockets. Well, there are sockets. There are 5 sockets for these particular bulbs. First socket can be filled with any of the 5 colors, 4 colors, 3 colors, 2 colors, and 1 color. Therefore, the total is R factorial. If there are 5 bulbs, 5 factorial, 6 bulbs, 6 factorial. Right? Okay. Now that's a relationship. What I want you to remember is these words. I want you to remember. I want you to remember these words. That is nothing but total arrangements are nothing but selections first, and then arrangement of the selected. Now, what happens in the question is either they restrict our selection or they restrict our arrangement. Either they restrict our selection, which means when you go to the shop, hey, don't buy or don't bring red colored bulb. Don't bring red colored bulb. What did I do now? I restricted the selection. Sometimes while arranging, we'll say that, hey, let red not be the first color. Or let yellow be not the first color. Once you are arranging, I'll say that, hey, in the beginning, don't put the yellow there. Or let yellow not be the first color. So therefore, what I'm trying to say, I'm trying to limit your arrangement. Therefore, can I limit your arrangement arrangement? Yes. Can I limit your selection? Yes, you can limit my selections. You can limit my arrangements. That's possible. No, that is what we'll see now. All right, let's see now. So, but keep this in mind. What is the total arrangements are nothing but selections first and then arrangement of the selected ones. Selections first and then arrangement of the selected ones. Here we go, friends. Let's go here. Let's take one of the simple examples built on this concept. Let's take one simple example. Let's take a simple example. Please read for yourself. Read it for yourself quickly. Yeah, here we go. Let's take a look at this. Yes. So what does it say? There is a flag. There is a flag. It has 4 stripes. I'll tell 2 perspectives. Right now, because so far we learned how to arrange directly also. Can I do that? Of course you can do that. Look, all right, now there are 7 colors. Vibgyor. Let me do the first perspective. What is the first perspective? Directly arrange. Why? Because that's what we learned in the last 50 minutes. If you have learned that, can I use it? Of course you can use it. Wherever it is possible, you can use it. There is no problem. So first concept that I'm using is what? Vibgyor. All right, the first concept is what? Direct arrangement. Now listen, how do I use the direct arrangement? So whenever there is an external limitation, I already told you, right? Now a limitation. Whenever there is a limitation, first work on that limitation. Guys, even for your CAT preparation, work on your limitations first. What you are good at can be done anytime. Say for example, hey man, I'm good at DI. Don't worry about DI. DI can be consolidated even in the 11th hour because you are already good at it. Right now, assume that my RCs are not good. It is the time to work on the limitations first because limitations give you bulk of marks. The moment you already open up a little bit of limitation, you make inroads into it, you suddenly see the surge in marks. Already your output is going to be much more higher. So therefore, always in life, work on your limitations. I'm not saying that you should not consolidate on your strengths. That can be done later. All right, that can be later. That can wait. Limitations can't wait. Right? Limitations can't wait. Limitations need to be addressed for. That's a way of life. That's a way of life if you want good growth. All right, if you want good growth. All right, let's see a life. Let's do a look here. Let's take a look here. Vibgyor. All right, now, so these are the colors of the rainbow, Vibgyor. Right, yeah. So then 7 colors. At least you should know that 7 colors, even if you have forgotten which are those colors, that's all right. But you should know at least the colors of the rainbow. So there are 7 colors on the rainbow, spectrum of light. Okay, so here we go. So what is that it said? Each stripe should have a different color. Fair enough. Each stripe has a different color. So 2 colors. So let red and blue must be there. Now you got even before you forget. Don't say that, okay, hey, I was busy coloring all of this. Oh, I forgot to paint the red color. Don't say that. Right now, because there is a limitation, red and blue must be there. So you better use it first. Therefore, what you say, you lift this red color. You lift this red color. Now use that red color, friends. Red color can be used on what? Any of the 4 stripes. There is a first stripe, there is a second stripe, third stripe, and fourth stripe. Where I should use wherever you want. Assume that this is red. Fair enough, fine, done. Stripe 3 used at red. Absolutely no problem. Now take blue. Now take blue. Blue can be used. Why blue? Because these are the 2 colors which have a limitation restriction. This must be used. You better use it before you forget you use it. Blue can be used in how many ways? Remaining 3 ways. Remaining 3 ways. Either stripe 1 can be blue, stripe 2 can be blue, stripe 4 can be blue. All right. So I said that stripe floor is blue. No problem. It's a dummy here. You can write blue anywhere there. You can write anywhere there. All right. Now what I do? Come to the stripe 1. Come to the stripe 1. What I can do on the stripe 1, red is used and blue is used. Okay, what about the stripe 1? On the stripe 1, you can use violet, indigo, green, yellow, orange. You are saying that, okay, on the stripe 1, I can use any of the 5 colors. Any of the 5 colors. Perfect. Any of the 5 colors. Already any 5 color. Already 5 ways. Any 5 colors. Assume that, okay, you used an orange. Used an orange. Used an orange color. No problem. Any color. All right, now stripe 1. Hey, what about stripe 2? Orange is gone. Orange is gone. Therefore, stripe 2, you can use any of the remaining 4 colors. You can use any of the remaining 4 colors. Now, that's a required answer there. All right, that's a required answer there. Right, that's a required answer. All right, therefore, all right, what is the required answer? 12, 60, 60, 240. You are saying that, okay, I can paint this in, I can color this in 240 ways. Now, this is what? Direct arrangement, no selection. Did you select anything? Absolutely not. You said that, man, I know how to do my arrangements. I took it up. I have finished this particular deal. Now, you may wonder, all right, here one question may come. Hey, why am I using colors? On the other hand, I'm using stripe. Why I'm not consistent with color? Why I'm using stripe and color? See, basically, when you looked at the red, there is how many red colors? There is only one red color. But how many stripes were available? 4 stripes were available. When you looked at one blue color, color was 1. But how many stripes were available for contention? 3 stripes. You should always consider larger of the two. And then again, when you looked at the violet color, how many violet colors are there? There is only one violet color. Rather, if you look at stripe 1, stripes versus colors, friends, stripes versus color. If you look at stripe 1, how many colors will qualify? 5 colors will qualify. That is better. All right, that is better. Basically, think of larger of the two numbers. That's another thing your teachers would have said. I'm helping you to recall exactly what your teachers have said, because that's what the primary part is. If I'm able to recall those points, my half job is done. Applications, I can do it much faster, but then I cannot falter at these kind of places. Hey, why am I writing color sometimes? All right, why am I writing color sometimes? Why am I writing stripes sometimes? Because idea is pretty simple there. Idea is pretty simple. All right, now because the stripe is one, this one stripe can take many colors. Therefore, I'm writing that first. All right, because red and blue, I had no choice. But after that, I have a choice. Therefore, I'm thinking from stripes perspective. In other words, always consider the larger number. Consider the larger of the two. That's when you get the exhaustive counting. I hope all of you are able to recall what I'm trying to say here. Good. Second perspective, let's see what is the second perspective on this. Second perspective is what? Very methodical school thought. All right, methodical thought here. What is methodical thought? They will say that I will select first and then I will arrange. All right, fine. That's also another good school of thought. I'm not saying no to it. All right, these fellows will come and say that, look, man, we always select first and then we will arrange. Please do that. All right, please do that. So how you are doing this? There is a stripe. All right, this has 4 colors. Sorry, 4 stripes. There is a flag which has 4 stripes. Now you are saying that the colors, all right, there is V, I, B, G, Y, O, R. There are 7 colors kept there. All right, there are colors kept there. How many colors do you need? 4 colors you need, because you have 4 stripes which has to be colored with different colors. All right, 4 stripes with 4 different colors. So therefore, how many you need? I need 2. I need 4 of them. One of them has to be red, one of them has to be blue. Therefore, you are forming a selection. Set means selection. So what is that you want? I want a red, one way. I want a red, all right, one way. I want a blue, one way, because you can't forget these colors. Assume that these colors are kept in the living room. These colors are kept in the living room, and this flag is kept in the study room. This is kept in the study room. So you got to come to your study room to paint this. So, but then already now the colors are in the living room. Assume these are crayons or whatever. It's in the living room. But you decided that I will not get the all the crayons. I will take up only the crayons that are required. So you decided. So red and blue must be there. Good. You kept that one way. Anything that is mandatory is one way, friends. You took that red and you took that blue and 2 more colors, and you want to take 2 more colors. Yeah, how many ways I can take any remaining 2 colors? 6, all right, 5C 2 ways. All right, remaining 2 colors can be selected in 5C 2 ways. Why? Because the red has been already taken, blue has already been taken. Therefore, how many more colors are left here? All right, 1 color, this is second color, third color, fourth color, and fifth color. Out of these 5 colors, I want 2 more colors, any 2. You may say that no, violet and indigo I will take. Please take whichever the 2 you want, you take. So but therefore I write it as 5C2. What is this answer here, friends? 10 ways, which means your selections happened in 10 ways. Now you came to the arrangement. Assume, all right, now dummy, let me write the dummy colors here. You brought red, you brought blue, you brought violet, and you brought indigo. Assume it's a dummy, violet and indigo. Any 2 colors you can bring. I said that you brought violet and indigo. Fair enough. The first stripe can be filled in how many ways, guys? First stripe, you are here. First stripe can be filled in how many ways? 4 ways. Which are any of the 4 colors? Okay. Second stripe can be filled in how many ways? 3 ways. Instead of writing horizontal, I'm writing vertical. Next place can be filled in how many ways? 2 ways. Okay. Next place can be filled in how many ways? 1 way. Therefore, you selected the colors in 10 ways. Then you arranged those colors. How many ways you arrange those colors? 4 into 3 into 2 into 1 ways. After selecting, you arrange them in 24 ways, right? 24 into 10. You select and arrange. That's what I said, that a total arrangements are nothing but selections first. And means what? Into arrangement of the selected. Arrangement of the selected. Arrangement of the selected. Yeah, how many selections you did? 10 ways. Selections you did it in 10 ways. Arrangement of the selected you did in how many ways? 24 ways. 4 into 3 into 2 into 1. Right? 24 ways. Hey, what is the answer there? 240. This is another school of thought. This is another school of thought. First fellow, he did it directly. All arrangements. Right from the word go, that fellow did arrangement and he got the answer as 240. What this fellow did, he's another school of thought. He's saying that no, I will first do the selection and then I will do the arrangement of the selected ones. Works. Fantastic, that works. But this thought is also very important, right? Total arrangements are nothing but selections first and the arrangement of selected one. So these are all very fundamental and primary thoughts. I can't afford to forget these thoughts. That's a point. Therefore, I'm ensuring that okay, all these elements are in place. Once these are in place, looking at the application is not a problem. All right, you can do many applications built on that, but these principles need to be very clear to each one of us. All right, let's go to the next one here. Look at some of the questions, cat type. Look at some of these particular questions. I will pause here for about 2-3 minutes. I want you to think about some questions out here. I want you to think about some questions here. Okay, let me tell you what I meant by these symbols here first. All right, like what I meant by these symbols. How many 3-digit numbers can be formed such that the digit in the hundreds place is greater than the digit in the tens place, and the digit in the tens place is greater than the digit in the units place? Hey, what about the second question? Continue like this. How many 3-digit numbers can be formed such that the digit in the hundredth place is less than the digit in the tens place, which in turn is less than the digit in the units place? Similarly, third and fourth question. That's how you got to read that. All right, that's how you got to read these conditions, right? Okay, I'll give 2-3 minutes for you. 2-3 minutes for you. I want to take a close look at these questions. Please take a close look at these questions. We have a lot to cover, friends. Don't waste your time. Pull your pencils, pull your book, keep working. Yeah, well, guys, let's try here. Okay, how many 3-digit numbers can be formed such that the digit in the hundreds place is greater than the digit in the tens place, which in turn is greater than the digit in the units place? Take a dummy here. Take a dummy here. Always pay special attention to 0. That's my point. What is the set here? Where nothing is mentioned, consider all the digits from 0 to 9. 0, 1, 2, 3. Consider all the digits from 0 to 9. When nothing is mentioned, there is no limitation on digits because I want the exhaustive answer. Therefore, consider digits 0 to 9. I'm trying to do the first question for you. Well, it's 0 to 9. So now, so what you are trying to say here, that is, let's take, first of all, take the one set. One set, assume that 0, 1, and 2 are my digits. Select the set. Select the set because I need 3 digits anyway here. I need anyway 3 digits here because the distance in the 100 place is greater than tens place, greater than units place. Do I have a choice? No. But whenever you are making a test case, what I'm teaching you is how to make a test case. You should make a test case with 0 and make another test case without a 0. That is, let make a test case with 1, 2, 3. 1, 2, 3. You put this condition in place. The digit in the hundreds place should be greater than the digit in the tens place, which in turn should be greater than the digit in the units place. Put these conditions in place. Therefore, what you are trying to say, how do you write it? So if 0, 1, and 2 is the selection of yours, assume that, all right, now this case 1 is your selection. Case 1 is your selection. The smallest digit sits here. Second smallest digit sits here. And 2 sits here. Which means what? For this selection, only one number is possible. Only one number is possible. You may say that, hey, no, I have this selection case 2. This is my case 2. For case 2 also same. All right, no, 1 comes at the units place, 2 comes at the tens place, and 3 comes at the hundreds place. Therefore, only one number is possible, which means what? Hey, whether there is a 0 or not, whether you have a 0 or no 0, does not matter. One number is possible. The point is how many cases are possible. There is a case 1, case 2, like this. How many cases are possible? In the sense, how many selections are possible? Select what? Select 3 digits. Select 3 digits. Therefore, you look at 0 to 9. How many digits are there? 10 digits are there. How many you want to select? 10C3 you want to select. That's it. 10C3 you want to select. For every selection, how many numbers are possible? Only one number is possible. Therefore, you said that first, selection first. Select the digits. How many digits you require? You require 3 distinct digits because you have to write them in the descending order, my friends. Whenever you got to write the things in the descending order, all it undoubtedly you need 3 distinct digits. Therefore, you said that 10C3. I need 3 distinct digits. All right, that's a selection first. Arrangement of selected ones according to condition. How many arrangements are possible for each selection? Only one arrangement is possible. Only one arrangement is possible. This answer is nothing but 10 into 9 into 8. All right, divided by 3 into 2 into 1. That's how you write 10C3. Okay, how you write 10C3 is write 3 numbers starting from 10. 10 into 9 into 8. Let's write 3 numbers. What is the 3 numbers here? Start where? Start from 10. In the denominator, simply take this 3, write 3 factorial. That is 3 into 2 into 1. Simplify this. Let's simplify this. Let 2 4 times. Therefore, you will say that there's nothing but 120. There are 120 such numbers possible. Simple. That's answered the first question. For the first question, how many numbers are possible? 120 numbers are possible. All right, 120 numbers are possible. That's about the first question. Let's come to second question, my friends. All right, same set of data. Same data. We have these 10 numbers here. Same set of data. So let's see all it now. So what is the result for the second question? Let's think about the result for the second question. So hundreds place has to be less than the tens place, which in turn has to be less than the units place. All right. Let's take a number. Again, one case. All right, let's take 2 test cases. One case has a 0. Other case has no 0. You may say that, okay, when you are writing the another case, another case, should I necessarily write 1 2 3? No, write anything which is non-zero. That's all I meant. Write anything which has no 0 in it. So therefore, easier example is 1 2 3. Thinking 1 2 3 is easy. That's all. That's all. You can write anything. 2 test cases. Technically 2 test cases. All right. So what is the test here, guys? Hundreds place should be less than tens place, less than units place, which means when I'm trying to arrange 0 1 2, 0 comes here, 1 comes here, and 2 comes here. If I write this, will it become a 3-digit number? No, it does not become 3-digit number, which means I got 0 numbers here. I got 0 numbers. When I wrote 0 1 2, 0 came and sat here. So therefore, all it, I am not forming a valid number. This is not a valid number. Okay. What if my digits are 1 2 3? That's fine. 1 sits here, 2 sits here, and 3 sits here. There is only one ascending order possible. So now what you are trying to say, okay, although you have given me 0, I can't use a 0 because whenever I use a 0, 0 comes and sits at the hundreds place. Thereby, it doesn't allow me to form a 3-digit number. Therefore, all it, you say that 0 cannot be used, which means all it, no, author did say that. You realize based on the condition, you realize that 0 cannot be used. Although you are given all the digits from 0 to 9, you are not able to use a 0 because it fails the condition. Therefore, you say that 9C3. 9C3. Why? Because 0 cannot be used. If 0 cannot be used, I can use any of the remaining 9 digits. All right, therefore you are forming 9C3, and only one number is possible for every case. All right, now look at this particular case. This particular case, when you took 1, 2, 3, how many numbers were possible? Only one number. Therefore, what you are trying to say? Selections first. How many selections? 9C3 selections. How many arrangements per selection? Only one arrangement per selection. Only one arrangement per selection. Therefore, you say 9 into 8 into 3 divided by 3 into 2 into 1. All right, that's 4 times, and this 3 gets cancelled. Therefore, you are saying that this time I can form only 36 numbers. All right, this time you are saying that I can form only 36 numbers. I hope everybody all right now it's making some sense what you are trying to count here. So therefore, what is the point? Point I'm trying to make is, look, sometimes the selections first and then arrangement of the selected is a very powerful thought. You can't all right now debunk that particular thought. That's a very powerful thought which simplifies the problem. Now think about that. You try to make a pattern out of this, it will simply take time. All right, now this takes so easy. All right, now so if you just understand that selection first and then arrangement of the selected one. Of course, while selecting there could be a limitation. While arranging there could be a limitation. Fine, all right, we can deal with those limitations. That's what we learned. All right, explicit restriction. All right, we learned how to deal with the limitation. Life is about limitations. All right, life is about limitations, dealing with the limitations. Good. All right, now here we go. Next one. All right, here we go. Third question. Let's go to the third question here, friends. Okay, all right, let's go to the fourth one, then we'll come back to the third one. I'm doing the fourth question here, guys. I'm doing the fourth question. I'll come back to the third question in a while. Let me do the fourth question first. Digit in the hundredth place. Digit in the hundredths place is greater than the digit in the tens place. Hey, what about the units place? Because if you are forming a 3-digit number, there are 3 places: hundreds place, 10 place, and units place. Here, units place, no restriction. No restriction. What do you mean by no restriction? Use any 10 digits, 0 to 9. Use any 10 digits because there is no restriction. All right, there is absolutely no restriction. Nowhere I use the word distinct as well. It is automatically becoming distinct in the first 2 cases. That's a different issue because that's an ascending order and descending order. It is becoming automatically distinct. But did I mention distinct? Absolutely not. Be mindful about the words in the exam. They don't have to use the word distinct, etc. It is understood by the way the question is constructed, the way they built the question. That itself signifies that what are the elements to be considered. They will never deliberately use the word restrict. All right, now distinct, no distinct. Hey, don't fall for those words. You may not find them. All right, let's go here. Let's understand because they intelligently use the language. All right, thereby you'll be able to understand what are the language skills involved in that question. Okay, let's go here. Hundreds place is greater than tens place. That's all the condition is good. So what about the units place? No limitation. What do you mean by no limitation? You wish you can use any digit from 0 to 9. All right. So now let's come back to this part. If the hundreds place has to be greater than tens place, I need to be picking 2 numbers. From this particular set because distinct. I cannot pick the same number only for this. Now unit place is over. I'm only talking about the hundreds place and tens place. I definitely need 2 distinct digits for hundreds and tens places. So okay, so can I have a 0 and a 1? Yes. Can I have a 1 and a 2? Let us check. If I take a 0 and a 1, hundreds place should be greater than tens place. 1 comes here and 0 comes here. Perfect. Hey, what if I have 1, 2 case? 2 comes here and 1 comes here. No matter which case you take, you will have exactly one formation of a number after selecting 2 distinct digits, right? Yeah. So how many ways I can select 2 distinct digits? 10C 2 ways. I selected 2 distinct digits. Why? Because there may be a 0 or there may not be a 0. Either ways it works for me. Okay, 10C2 into how many numbers can be formed out of that selection? 1. And what you do, and you come back and write the units place of your choice. Which means, all right, now let me write a dummy example. I formed a number 100. That's fine, guys. That's fine. 100 is a 3-digit number. All right, now in which hundreds place is greater than tens place and units place has no limitation. This number is fine. 100 is one of those numbers I'm talking about. Okay, what is the answer here, by the way? Therefore, all right, now what is the answer to this question, by the way? 10C2 is 10 into 9 divided by 2 into 1. All right, into 10. All right, into 10. All right, therefore you would say that this is 5. Answer is nothing but 450. There are 450 such numbers where hundreds place is greater than the units place in that particular 3-digit number. That's a required answer there. All right, that is the required answer. Let's go to the third question now. Let's now go to third question. The digit in the hundreds place. Listen carefully. This is one of the beautiful questions. Therefore, I'm taking it towards the end. It's a beautiful question, right? Now, this completely summarizes all our points out here. So, right, firstly, hundreds place is greater than tens place. Or the tens place is less than the units place. Now, this can be done in 2 ways. Number 1, all right, I can have only 2 digits and do that case 1. Case 1, I have only 2 distinct digits. And I can do this particular question. Case 2, I may consider 3 distinct digits. I cannot do this condition satisfied with 1 digit, right? 3 distinct digits is also fine. First, let me take 2 distinct digits, guys. 2 distinct digits. Let me go to the sample size and let me pick 2 distinct digits, 0, 1, let's say. I filled 0, 1, or second case I will take here is 1, 2. Let us handle both the cases here. So hundreds place should be greater than tens place, less than the units place. If I pick 0, 1, 0 comes here, 1 comes here, and 1 comes here. That's it. That's it. That's it. Only one number. If you have picked 0 and 1, if you have picked 0 and 1, you can form only one number called as 101 based on the condition, because the tens place is the least number, right? Now similarly here, when you're writing 1 and 2, when you're taking this particular number, naturally 2 and 2 gets repeated and 1 will sit here. That's it. All right, now smallest of the numbers will sit at the tens place. The larger of the 2 gets repeated. Therefore, what is that you are trying to say? For the case 1, answer for the case 1 is I have to select any 2 digits. Select any 2 digits. Out of how many digits? Out of 10 digits. Therefore, you are saying that 10C2. Okay, I selected. After selecting, how many arrangements are possible? Only one. Why? Larger digits you have to repeat. Larger of the 2 digits you should repeat. Smaller digit will come and sit at the middle. Smaller of the digits will come and sit at the middle. Therefore, 10C2 into 1. Case 1. Case 1 is what? 10C2 into 1. Select any 2 digits. Smaller of the 2 digits, put it at the tens place. Larger of the 2 digits, repeat it. Thereby, your condition gets satisfied. Or all right, now that's what you are saying, that case 1 is what? 2 distinct digits or 3 distinct digits. I can satisfy this inequality by using 3 distinct digits as well, in the sense, okay, what if I would have taken 0, 1, 2? Let me take this particular case. Let us check that. Hundreds place, tens place, and units place. All right, units place. Okay, so what is that? What is at the hundreds place, friends? All right, what can I write at the hundreds place there? So let us check that. Okay, if I write 0 at the hundreds, 10 or 0 at the tens place. If I write 0 at the tens place, hundreds place can be 1. At the hundreds place I can write 1. At the units place I can write 2. Or I can write 2 here, 0 here, 1 here. That's it. There's 2 numbers can be formed. Now you are saying that, okay, I can form 2 numbers using this particular set. I can form 2 numbers using this particular set. If I select the 0 set, okay. What if I don't select a 0 set? In the sense, now you are saying that, okay, I select 1, 2, 3. I select this. I select this. Hundreds place greater than tens place, which is less than units place. Let's put this again. 1 has to sit here. Either you can write 2, 3 here, or 3, 2 here. So therefore, again, you can form 2 numbers. Therefore, what is that you are trying to say here? If I select 3 distinct digits, how many ways you can select? 10C 3 ways. 3 distinct digits. How many numbers I can form for each selection? For each selection, you can form 2 numbers. For every single selection, this is a selection. How many numbers did you form? 2 numbers you formed. If this was one selection, how many numbers you formed? 2 numbers you formed. Therefore, what is that you are trying to say? 10C3 into 2. So sum of these 2 numbers, see, that is where the or is coming in the picture, right? I can form my third question either using 2 distinct digits or by using 3 distinct digits. Whenever you say or, what you should do, you should multiply the cases. 10C2, you got to multiply this with 10C3 into 2. All right, now that's all right. Now sum of these 2 numbers is your answer. I hope everybody got this concept here. So what is that I was trying to illustrate through this example? Sometimes it is inevitable. It becomes faster provided you do selection first and then arrangement of the selected ones. Therefore, if you look at this particular example, that's what we did. 10C3 means what? I focused on selection. What did I do? I focused on selection. What did I do? I focused on selection. I focused on selection. I went on to focus on selection more often than not. Remember that. I focused on selection and then I went on to do the arrangement of the selected ones. It's one of the powerful thoughts, no doubt. It's a fundamental, yet it's a very profound thought. Right. Okay. Now this is what we do, guys. All right, let's go further. Let's go further. I hope everybody's getting hang of this. Everybody's getting hang of this. Another fundamental, let us do circular arrangement. Circular arrangement. So far, what we did in the last 1.5 hours is more to do with the linear arrangement. Right? More than selection, the focus was on arrangement. Sure, we'll come back to selections at a later stage. The selections also has their own, they also have their own importance when it comes to management entrance exam. But we'll come there. We'll come to that portion. Let's take a look at this circular arrangement. Let's focus on the circular arrangement. Okay, let me illustrate by using this simple point here. All right, let me illustrate by using this simple point here. Now listen to me carefully. I took one of the tables. Let me call this as the table 1. Around the table 1, I put 3 chairs. Around the table 1, I put 3 chairs facing the center. All right, facing the center. And I had another one, table 2. Table 2, same way. All right, there are table 2, which means second way. All right, now third is table 3. Say this is my table 3. Okay, what happened is one day A sat here, B sat here, and C sat here. Right? The second arrangement, second day. Second day they went to the table 2, and then A sat here, Alright, A sat here, B sat here, and C sat here. Third day, alright, A sat here, C sat here, and B sat here. Alright, third day B sat here. My one question here is, did they sit differently? Alright, did they sit differently? Think about it. Did they sit differently? Alright, now, so this is how they sat. Day one, they sat around the table one in that fashion. Day two, they sat around the table two in that fashion. Day three, they sat like that around the table, alright, table three in that fashion. My question is, did they sit differently? Alright, did they sit differently on these three occasions? Did they sit differently? No, very good. All right, your response is right. All right, no. It is all the same arrangement. Why? Now look at this. B is sitting. All right, now B sits. All right, B is sitting. All right, in this arrangement, in all three arrangement, B is to the left of you. B is to the left of A. Take any arrangement, any of the three arrangements I've written here. I'm not doing this question, don't bother. I'm not doing this question for now, don't worry. I'm just telling you the importance of circular arrangement, how it is different from linear arrangement. That's all the point I'm trying to say here. B is to the left of A. That's a point one here. B is to the left of A. Look at any three arrangements. B is to the left of A. They are facing the center. Follow the arrows. All right, follow the arrows, not your right or left. A's left. B is to the left of A. Similarly, C is to the right of A. C is to the right of A. Any arrangement that you say. C is to the right of A. That's it. That's it. Therefore, what? All the arrangements are same. Because all right now it's not changing at all. Therefore, it is same. All arrangements are same. You may look like all right now it is different, isn't it? It looks different. It looks different. But technicals behind this question are same. B sits to the left of A and C is to the right of A. That's it. Over. So thereby all three arrangements are same. Therefore, hey, where did you make a mistake? You made a mistake because you did not take the reference. The way what I'm trying to do here, I took A as the reference. I tried to explain this to you in case already you would have misunderstood, right? What did I do here? I took A as the reference. I tried to look at both B and C with A as the reference, friends, with A as the reference. Now listen to me very carefully, each one of you. Listen to me very carefully. Therefore, the first person whoever walks becomes a reference here. Let me take 4. All right, now let me take the same for example here. Listen carefully. Let me take the same for example. A, B, C, D are 4 folks. Assume that all right now they approached. All right, now they want to sit on these 3 chairs, linear. Assume that they want to sit on these 4 chairs, A, B, C, D. Now this is a board. All right, now there is a board here. They want to see the board. All right, they are facing that particular board. 4 chairs are there. I said that, hey guys, come sit here. 4 boards. Now see, the first place has a name. Hey, what is this particular name? You say that all right, far left. This is far right. All right, leftmost, rightmost. This is second to the left. This is second to the left. This is second to the right. This is second to the right, second to the left, and second to the right. All 4 positions have a name. Assume that out of A, B, C, D, A wanted to sit first. A wanted to sit first. A can sit in 4 ways. Why? He may say in his mind that, okay, I will sit to the left, I will sit to the right, I will sit second to the left or second to the right. Therefore, there are names. There are names here. So therefore, 4 ways. What about the second person? 3 ways. Or next person, 2 ways. Next person, 1 way. Because all names are fixed here. 4 into 3 into 2 into 1. Therefore, you are saying that 4 factorial, right? 4 people can sit along this particular linear table with 4 chairs in 4 factorial ways. Simple. All it now. So put it around the circle, equal gaps. Put it around the circle with equal gaps, like this. All right, now they're all facing the center. Let's assume they are facing the center. Okay, it need not be north, west, south, etc. That's not the point here. So you cannot say that it is north, it is south. No, I don't know. All it knows is just that there is a circular table. Assume that it is kept in a desert or it is kept in a jungle. In a jungle, already if you go into a thick jungle, you don't know what is north, what is south, what is east and west. All that nothing. You just all it know. So you decided that okay, you went for a jungle safari. Now it's solid. Now it is solid. Now so you went deep into the jungle. You don't have the already now. You don't have enough sunlight out there. Cloudy day, so therefore you don't know which is north, which is south, etc. Simply there is a circular table. You have sat there for a coffee. Already you wanted to discuss something there, so you sat there for a coffee with 3 other people. So which is north, which is south does not matter. A first walks in. A first walks in. So now here, if it is a linear table, even if it is in a jungle, left exists, right exists. Right exists, second left exists, second right exists. Now when A, B, C, D are sitting around this particular table, A comes out first, just like other day. Just like other day, A comes out first. This time he finds a circular table. He finds a circular table. Where should I sit? There is no name. There is no name. Therefore, A says that I can sit anywhere. It is only one way. Assume that A sat here. A sat here. One way. That's it. You may say that A sits here is different. No, it is not different, friends. This A, already if you want to bring this A to this particular position, simply tilt it. Simply simply say rotated by 90 degrees. Rotated by 90 degrees, A comes here. Therefore, it does not matter. A sits in one way. The moment A sits, the names come in the picture. Assume B walks in. When B walks in, this is opposite of A. This is left of A. This is right of A. Now there are names. There is a left, right, opposite. Names have come in the picture. So far there were no names. When A was going, there was no name for the position. The moment A took his seat, all right, now the moment A took his seat, now there are names. There is a left, there is a right, and there is an opposite side. Therefore, when B goes there, he can sit in three ways, because he can say himself, I want to sit to the left of A, or I want to sit to the right of A, or I want to sit opposite of A. Now, one of the positions would have been blocked. Therefore, C sits in two ways and one way. Therefore, remember, friends, when four people have gone to a circular table, your answer was 4 factorial. When the same four people wanted to sit around a circular table, your answer was 4 minus 1 factorial way. Nothing but 3 factorial. What I'm trying to say, 3 factorial here. So why? Because A sits in one way. Leave that. Rest of them can sit in 3 factorial way. Hey, what is this one way? A, the first person creates a reference. Right? Whoever goes first, A, B, C, does not matter. The very first person who walks to that particular table creates a reference. Therefore, others can sit around that reference. Others can sit around this reference. I hope you got a very basic understanding here. Very basic understanding here. N different things, N distinct things. N distinct things. If it is a linear table, already your answer is going to be n factorial. Arrangement of n different things in a linear order is n factorial. Arrangement of n different things in a circular order, alright, in a circular order, is n minus 1 factorial thing. Say, what is that one? The first person forms a reference. Therefore, n minus 1 people can arrange themselves around this particular first person. Therefore, n minus 1 factorial. I hope you got the point of this minus 1 here. If you got that minus 1, there are variations in this question. Alright, there are variations. Alright, no, so around in the circle itself, there are variations. Let's see these variations, because this is in these variations is where the people get caught. Alright, yeah, this is fine. N minus 1 factorial is perfectly fine. Linear, n factorial. Circular, n minus 1 factorial. Thought is bang on. But there are variations. Let's take a look here, friends. Let's take a look at these variations. Those who kind of already know the basics, go through this. Go through this and put your answers to these 3 questions out here. I'll come back in a minute and do them. Read these questions. All 3 questions are different. Numbers are same. Questions are different. Because there are 3 variations in circle. Try and get those 3 variations out here. That's my point. Yeah, okay, it's fine. Let's take a look at this. Good, let's take a look at this. So what is the point I'm trying to say? One, all right, first you got to understand that, all right, now there are 2 perspectives here. Is this a vertical perspective or is this a horizontal perspective? Horizontal perspective, which implies sometimes, all right, now it can be a circular arrangement, but it can be put, say for example, assume that there is a circular arrangement. I have a red color on the top. So I have blue here, blue color, all right, now blue colored circle there, all right, now blue color ring. There is a red ring I have put here. There is a blue ring I have put here. There is a yellow ring I have put here. The orange ring I have put here. All right, now it is like a vertically, all right, it is hung. All right, vertically it is hung right in between the room. In between the room, you have a circular ring. To that particular circular ring, you have kept another ring, circular ring here, red color. There is a blue color ring here. There is an yellow color ring here and an orange color ring here. All right, now it's like a ring. All right, to one larger ring, you kept these smaller rings, and you are hung right in between a particular room. Assume it's one of the part of a decoration, right in between the that particular room. In the sense, this ring can be seen from two sides. This particular ring can be seen from two sides. From one side, red, blue, yellow, orange are in clockwise direction. Red, yellow, blue, orange, blue are clockwise direction. Just go to the other side, flip to the other side, go to the other side and check. All right, in one way, red, blue, yellow, orange are in clockwise direction. The way we are seeing it, it's clockwise. What if the fellow sees the same arrangement from the other side? All right, just go to the other side of the issue and see it. He will find red, blue, yellow, orange in anti-clockwise direction. All right, he says that, hey man, for me, red, blue, yellow, orange are anti-clockwise direction. That is what that fellow would have said, which means clockwise for somebody can become anti-clockwise for somebody as well. Whenever it becomes a vertical perspective. Whenever it becomes a vertical perspective, assume that you are a designer. You designed this particular wheel. You designed this particular wheel. One customer came to you and he said that, hey, look, all right, now, so I want red, blue, yellow, orange in a clockwise direction. You sell this wheel. Another customer who overheard this, oh, okay, the earlier customer took red, blue, yellow, orange, all in the clockwise direction. I also wanted the same colors, but I want in the anti-clockwise direction. He gives the same thing, same ring he will give, but he will just turn it and give it to you. He'll say that, okay, sir, you place take it like this, ma'am, you take it like this, because now here, red, yellow, blue, green are in the anti-clockwise direction. Did he manufacture it? Did he design a separate one? Or it quickly took time and then put them together in a separate one? Absolutely not. Same model, what he gave to the first customer, he gave it to the second customer. Therefore, remember, if it is a vertical perspective, which means any arrangement can be held vertically, and if it makes the same sense, your answer will become n minus 1 factorial by 2. All right, factorial by 2. If it is a horizontal perspective, it becomes n minus 1 factorial. When it is circular, which means in the circular there are two cases. One, all right, is this question belongs to vertical perspective? Is this, all right, no, question belongs to horizontal perspective? If it is a vertical perspective, it should be divided by 2. It should be divided by 2. Otherwise not. Otherwise not. Okay, you just remember that even if you didn't understand much of my explanation, doesn't matter. You just think that, okay, can I hold this vertically up? If the arrangement can be held vertically up, divide by 2. If it cannot be held vertically up, don't divide by 2. That much be sure. All right, now that much be sure about. These are the two models. Let's take a look at the first two questions now. With this understanding, let's take a look at first two questions, my friends. Let's take a look at first two questions, everybody. Let's take a look at first two questions. First one, in how many ways 10 children can be made sit on a circular table with 10 chairs? All right, there is a circular table. There are 10 chairs kept there. There are 10 chairs kept there. All right, there are 10 chairs kept. There are 10 chairs kept, something like this. There are 10 chairs which are kept around this circular table. Good. All right, now, so around this particular circular table, 10 chairs are kept. So what is that we are trying to say? Yeah, so just 10. All right, now, so it may not sound like 10. All right, there are 10 chairs which are kept there. All right, the circular table, 10 chairs are kept. Now the kids are watching. All right, kids are sitting around this table. Assume there are 10 positions here, 10 chairs are kept. Kids are sitting around here. Okay, and they're having they are sitting around with a circular table for dinner or whatever be that particular event, let's say. So what is the answer here? Because they're sitting around a circle, you know that you must write 10 minus 1 factorial for sure. But the doubt that comes to your mind is what? Should I divide this by 2 or not? Should I divide this by 2 or not? No, you don't have to divide this by 2. Why? Because it is not the vertical arrangement. You can never hold this up vertically. In the sense, you will say that, okay, no, table, chair, everything, I will start, I'll put them in the vertical. The kids will start eating in the air. I can see from this side, I can see from that side. No, it's a horizontal ground. You are not watching any Harry Potter movie out here, right? So therefore, it's just a horizontal arrangement. Therefore, it becomes n minus 1 factorial. Therefore, you say that answer is 9 factorial. 10 minus 1 factorial. Technically, you are trying to say that answer to the first question is 9 factorial. Take a look at the second question, friends. In how many ways 10 different flowers can be put together to form a garland? All right, now 10 different flowers need to be put together for a garland. Garland, all right, now garland is circular in nature, no doubt. And also, all right, now so it has one, all right, also it has been fixed, and then it's a circular. It's not a non-linear, it's a circular, right? It's a circular. Therefore, all right, so you are looking at the garland. So you put one flower here, you put the second flower, third flower, fourth flower. Likewise, you put all 10 flowers around this. All 10 flowers around this. Hey, can I hold this up vertically? Which means, is it possible to hold it vertically? Yes, of course. Of course, it's possible to hold vertically. Therefore, can it be seen from both the sides? Yes, it can be seen from both the sides. 10 different flowers are used. Therefore, answer is going to be 10 minus 1 factorial divided by 2. That's a difference, friends. Right? Garland was an example of vertical perspective. The kids, when they were sitting around a circular table, was an example of horizontal perspective. Horizontal perspective. Now take a look at the third one. Now take a look at the third one, friends. Take a look at the third one here. Take a look at the third one. Take a look at the third one. Beautiful question. Beautiful question, right? Third one. All right, let's take a look here. In how many ways 10 different colored beads can be put together to form a necklace? To form a necklace. Ultimately, after wearing, the necklace is circular in nature. All right, non-linear. After wearing. But before wearing, all right, before wearing, the necklace has opened. Necklace has opened. There are hinges here. While wearing, all right, just like a garland. Hey, how do you put the garland? All right, garland, you already know, so you don't open and then wear and bind it. Garland, you just put it, all right, put it across. All right, garland, you just put it across, all right, across as it is. All right, garland, you wear it without opening. Necklace, what you do? You open and then wear. Necklace is never worn like this. All right, now, so if you don't have, all right, you got to watch, all right, now how ladies wear the necklace. All right, they'll not fling it into their neck. No, all right, they open that, all right, they open and then they will put it together. Therefore, it's linear. It is open means what? Linear. All right, therefore 10 different colored beads, all it can go in how many ways? 10 factorial ways. Why? It's linear. While you are forming a necklace, it's a linear, my friends. It's linear. It is not circular. All right, it's not circular. Garland, when you buy from the shop, it is circular in nature. Necklace, all right, it is not circular. While you are wearing, think about the way we are wearing. While wearing, it's not circular. It is linear. Therefore, it is 10 factorial. All right, that's therefore it is 10 factorial. Second point. Second point. But in necklace, there is a horizontal perspective or vertical perspective. That question comes. Be it linear or non-linear. All right, there is a horizontal and vertical perspective always comes. Whenever it's a vertical perspective, you got to divide by 2. That's what I meant. Whenever it's a vertical perspective, you got to divide by 2. All right, whenever it's a vertical perspective, divide by 2. Horizontal perspective, you don't have to divide by 2. Technically, I was talking about two things. Circular perspective, -1. All right, n minus 1 factorial. The moment it is a circular perspective, n minus 1 factorial. Now, within that circle, is it a horizontal perspective or vertical perspective? If it is a vertical perspective, divide by 2 factorial. Similarly, linear perspective. All right, no, not a circular, linear perspective. N different things, n factorial. But if it is a vertical perspective within that linearity, remember to divide by 2 factorial or divide by 2. 2 factorial is nothing but divide by 2. Therefore, answer to the third question is 10 factorial divide by 2. I hope all of you got the meaning of vertical perspective and horizontal perspective. And you also got the circular perspective and linear perspective or non-circular perspective. I hope all of you got the difference between these 4 elements. All right, these 4 elements. Good. Look, I'm giving the points here. I want you to understand them very clearly. Once you understand, there is hardly any chances that you will make any fundamental mistake here. All right, you will not be, you won't be making any fundamental mistake. All right, guys, one last concept. One last concept before we call it a day. So last 15 minutes, push yourself. Push yourself. We are to the last 15 minutes. Let's learn that one last concept. I guess for some of you it could be a little heavy because counting is a little heavy, no doubt. All right, counting could get a little heavy. Doesn't matter. All it doesn't matter. Let's push last 15 minutes. Therefore, push yourself. Gap and string method. Very, very important. Just read through the questions. We'll do it together. We'll do it together. 10-15 minutes. We'll wrap it up. We are done. Gap method and string method. Pretty important methods. Yeah, okay. What is gap method? All right, the key word for gap method is no two, no two, no two or together. Whatever, no two vowels, consonants, whatever be it, no two boys, girls, whatever it could be. Right? The key word, key phrase is no two things are together. That's a key word. No two things are together. What are those things? It'll have some name. Let's not worry about it. No two things are together. All right, these are the profound thoughts. You got to keep it in your mind. All right, this when it comes, we use the gap method. Whenever no two things are together, when that phrase comes, we use a gap method. I'll illustrate the method. It's a method, therefore it's pretty easy to learn. Right? I'll illustrate that method. Second one, all vowels are together, all are together, all of a particular type are together, all are together, all things are together, all. The word is all. No two are together, all are together, all are together, all together, no two together. Right now, these are the very two important ones. This is called as a string method. This is called as a string method. A very high school question, 10th standard. All right, now gap and string methods are technically learned somewhere towards the 10th standard. All right, in some boards you learn during the 10th standard. Very good thoughts. So already in management entrance exam also use this thought so often, direct or indirect in many ways. We'll see those ways later. But it's a very important thought there. And what about the third one? Combination of both. We'll come back to that later. We'll come to that later. The first two questions. Let me illustrate the first one. What is that author is trying to ask us? He's saying that, hey, how many ways one can arrange the letters of the word special such that no two vowels are together. All right, where are the vowels, guys? E is a vowel, I is a vowel, and A is a vowel. So technically, you are trying to say that there are 4 consonants and 3 vowels. What are the consonants? All right, what are the consonants here? All right, S is a consonant, P is a consonant, C is a consonant, and L is a consonant. Okay, what are the vowels here? The vowels are E, A, all right, A, E, and I. There are 3 vowels. Author is saying that, okay, these vowels should not come together. If the vowel should not come together, take your cursor, assume that if you have a mobile or whatever the laptop, just simply type these 4 letters. Type these 4 letters in any order that you like. In any order that you like. You said that, hey, I typed C, L, P, S. Fine. 4 factorial. Any order you can type these 4 letters in 4 factorial ways. Because there are 4 letter guys. 4 gaps. Alright, I said that, okay, why don't you fill this? Fill it whichever way you want. You filled it. Alright, you filled it. First place can be filled in 4 ways, 3 ways, 2 ways, and 1 way. That's what you meant here. Fair enough. Perfect. Alright, now you filled it. You filled it 4, 3, 2, 1. Assume that this is the dummy. Assume this is the dummy. You did this. Good. Now what I'm trying to say is, okay, there is no gap between them, but you can visualize the gap. Alright, in the sense you can move your cursor and you can insert a word, isn't it? So in a letter, if you make a mistake in a word while you are writing a particular word, whether on your laptop or while you are writing on your computer, or it can be on your, it can be on your mobile, you can come back and insert a letter. That's what I meant here. Now look, vowels, no two vowels are together. If the vowels are not together, what is separating them? Consonants are separating them. Therefore, vowel can be inserted here. A vowel can be inserted here. Guys, there is no gap as of now. There is no gap as of now. I'm saying that you can insert a vowel here. You can insert a vowel here. You can insert a vowel here. How many potential positions you have now? You have 5 potential positions, right? Yeah, you have 5 potential positions. First 1 position, second position, third, fourth, and fifth. You have 5 potential positions. But how many do you need? Only 3. I need only 3 potential positions. Very good. Select 3 potential positions. 5C3 ways. What is 5C3? You selected 5 potential positions, 3 potential positions. Good. You selected 3 potential positions. After that, what? After selecting those 3 potential positions, write the letters, arrange the letters in 3 factorial ways. Assume that you selected this position, you selected this position, and you selected this position. Once you selected these positions, any letter you can write. Can I write A here? Yes. No. I will write E here first. I will write E here first. You can write E here. You may think that no, yeah, I will write I here first, right? Yeah, whatever you want, you write. Therefore, that's a meaning you're calling it as 3 factorial, 3 into 2 into 1. So all of you understood that. What is that I'm trying to say? First, arrange consonants. Alright, when the vowels has to be separate, that's a method here. What is the gap method? No two vowels are together. If no two vowels are together, the primary question is what is separating vowels then? If no two vowels are together, there should be a separator. What is separator here? Consonants. Arrange the consonants first. Simply arrange. Don't leave any gap between them. Neck to neck, simply arrange the consonants. You arranged consonants in 4 factorial ways. Perfect. Then look for potential gaps. That's the reason we call it as a gap method. Look for potential gaps. Alright, you have 5 gaps. In those 5 gaps, but how many gaps you need? 3 gaps. Select those gaps. Once you select those gaps, arrange your vowels onto that particular gap, right? On into those particular gaps. So therefore you say that, okay, so first, all right, now that's what you mean by arranging the consonants and arranging the vowels. That's your answer. Arranging the consonants and arranging the vowels. Well, it gives me the complete 7-letter word. That gives me the complete 7-letter word. This is the answer to the first question, friends. That's the answer to the first question. Therefore, I illustrated the gap method very clearly to you. So which means, all right, now if no two vowels are together, first you need to understand what is separating them. Consonants are separating. Arrange them. Look for the potential gaps. Select the required number of gaps and arrange vowels into that particular gaps. Now answer looks like 4 factorial. That is arrangement of consonants. And then select the gaps for vowels, arrange the vowels. All right, that's about the first question. Let's come to the second question, friends. Let's come to the second question now. Let's come to the second question. Let's come to the second question. Second one. Right? The first one is a gap method. The second one is a string method. In how many ways can one arrange the letters of the word special such that all vowels are together? This time the vowels need to be together. Now listen to me carefully. All vowels need to be together. Let me write one of the dummy words. S, A, E, I, P, C, L. Now, are all the vowels together? Yes, here are the vowels together. Here are the vowels together. Now look at them. All right, now can I interchange an yes with C? If I interchange yes with C, will it be still valid word for the second example? Second question, yes, it will be a valid example. Why? Because what is the condition? Vowels should be together. All vowels are to be together. If you interchange yes and a C, if you interchange these two positions, will it be still a valid word? Absolutely, it would be a valid word. Good. But on the other hand, instead of interchanging yes with C, if I interchange E with C, if I interchange E and C, will it still be a valid word? No. If you interchange E with C, it will not be a vowel, or it will not be a valid word because you are splitting the vowels. Alright, you are separating the, you are splitting the vowels there. Therefore, it won't be a valid word. Fair enough. Alright, now that's a point you are trying to make. Alright, that is the point. Alright, now so therefore, what you do, you will say that I can move these vowels, I can move these consonants in isolation. Yes, I can shift wherever I want. P I can shift independently. C I can shift independently. L I can shift independently. But all right, now A, E, I put a string around them. I put a string around them because they will go as they will go as a triplet. They go together. They may interchange among themselves. In a sense, if there is an A, E, I here, you may say that okay, no, yeah, I will write I first and then I will write E for E next. That's fine. But within the string, you do whatever you want. Don't go out of the string. Don't step out of the string. That's important there. Don't step out. So therefore, externally, now look at that. Externally, how many groups I have? Externally, how many groups I have? First group, second group, third group, fourth group, and fifth group. 5 groups can be arranged externally in 5 factorial ways. In the sense, hey, can I change this entire group with this C or L, which means I bring L in between in the second place too, and then I will shift that A, I, E to the last. That's fine. That's fine. Perfectly fine. That's perfectly fine. You may say that, hey, can I shift the group 2 and 4 here? Yes, all right. No, so which means 4 I will bring it after yes, and the 2 I will shift it to this particular place. Will it be a valid word? Yes. Externally, you do whatever you want with these 5 strings. All right, now 5 groups. It will be a valid word. Fine. But for every external arrangement, without going out, these 3 fellows can arrange among themselves in 3 factorial ways. That is internal to that boundary, internal to that particular string. Within that string, those folks can arrange among themselves in 3 factorial ways. Therefore, what? An external arrangement followed by internal arrangement becomes my answer. That's how you tackle the string method. What do you mean by a string method? You put a string around the fellows who should be together. You call them as one unit. That's one group. One unit. Others are isolated units. Therefore, together you found that although there are 7 letters here, you found that there are only 5 units. Externally, 5 factorial ways. Internally, 3 factorial ways. That's your answer there. External arrangement followed by internal arrangement. Good, guys. Let's do the third one now. Let's do the third one. Let's do the third one. In how many ways one can arrange the letters of the word special such that not all vowels are together? I don't want every single vowel to be together. In the sense, hey, can I have no vowel together? Not all vowels are together. What's the meaning of that? No vowels are together. No vowels are together. No vowels are together. Fine. Exactly 2 vowels are together. That's fine. All right, now all 3 vowels are together. All 3 vowels are together. Not fine. All 3 vowels are together is not fine. No 2 vowels are together. No 2 vowels are together. No 2 vowels are together. I'm fine. Exactly 2 vowels are together. I'm fine. All 3 vowels are together. I'm not fine. How do I tackle this question? All right, now therefore these 2 cases put together, answer to the third question will be what? Total minus all 3 vowels are together. Total minus all 3 vowels are together, right? Okay, now what is the total, friends? Therefore, what is the total? Total is nothing but 7 letters in 7 factorial ways. There are 7 letters, special as 7 letters. Well, 1, 2, 3, 4, 5, 6, 7. 7 letters. 7 letters in 7 factorial ways. All 3 vowels together, we just have the answer here. Therefore, 5 factorial into 3 factorial. That's your answer. Well, this would be your answer. 7 factorial into this. In the sense, I just showed you that, okay, how we use this sometimes as a part of some particular question. 2 important methods, the gap and string. Well, gap and string, 2 important methods. Let's do one application on this quickly. All right, no, let's do this and we'll stop with this. Let's do this and we'll stop. Let's do this example, last example. Then we'll close the lecture. Yeah, okay. First one, 4 boys and 4 girls. First question. The 4 boys, in how many ways 4 boys and 4 girls can be made sit on 8 chairs kept in a row facing the cinema screen such that no 2 boys sit together. No 2 boys sit together, something like this. Here is the screen, guys. So there are 8 chairs kept here like this. There are 8 chairs kept there. They're all facing this particular screen. This is a screen. They're facing it. How many ways? Already 8 chairs. Already now 4 boys and 4 girls can sit so that no 2 boys sit together. No 2 boys sit together. Who should be separating them? Girls should be separating them. One way of doing this activity is what? Take all these chairs, keep it with you. Take all these chairs, keep it with you. First, all right, now you tell that girls, please go and sit. Please go and sit facing the cinema hall. All right, girls, you take 4 chairs because no 2 boys sit together. Who should be separating them? Girls should be separating them. Therefore, first you will say call 4 girls and give them, all right, call 4 girls, give them 4 chairs and say that go, please go and sit there. Now 4 girls go and sit here. Girl 1, girl 2, girl 3 and girl 4. 4 girls go with 4 chairs and sit in how many ways, friends? 4 factorial ways. They might not have left any gap in between them. No gap between them. No gap between them. They just sat there. 4 girls went and sat in 4 factorial ways. Simple. That's it. All right. 4 factorial ways they sat. Now how many potential gaps? Now you're saying that okay for the boys. Then you will say girl. Then you will go and request the girls. Girls, you just move little aside. Probably wherever the boys want to sit, they will come and sit. In the sense, what you are trying to say is potential gaps where all boys can sit. Well, a boy can sit here, 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 or a boy can sit here, which means how many potential gaps I see? 5. But how many gaps I need? Only 4. Potential gaps. There is no gap as of now. These 4 people are sitting neck to neck because they have no idea that the boys will come and sit in between us. No idea. Well, in the sense they are sitting simply neck to neck there. Fair enough. They're sitting neck to neck. Okay, but then wherever the boy wants, all right, you will go and request girls, you got to move little aside because I will sit, put a chair here because there is a limitation given to us saying that no 2 of us should sit together because if we sit together the show will not start, something like that. So all right, then the girls will make space for them. Therefore there are 5 gaps. Let's assume that these are the gaps the boys wanted to sit. Okay, the 1 boy wanted to sit here, 1 boy wanted to sit at the extreme, 3rd boy wanted to sit here, there is another boy which wanted to sit here. In that case, what happens? These 2 girls will be sitting together. Absolutely, absolutely. The gaps are 5, but how many gaps I need? Only 4. Therefore 5C4. I need 4 gaps. Now 4 boys, once you decide those 4 gaps, the 4 boys will go and sit in those 4 gaps in 4 factorial ways. That's answer, friends. Now what happened here? First girls sat together. Alright, because who should be separating the boys here? The girls should be separating the boys. After that boys and what? And boys sat. And the boys sat. Now before boys sit, there is a potential gaps which will be visualized and they decide which gaps they want to sit. Because here what happened here? Here the boys decided that nobody sits between girl 3 and girl 4, which means these 2 girls can be together. See, when I said that no 2 boys sit together, I never meant that no 2 girls sit together. Girls can still sit together. That's a point there, right? Yeah. So therefore, all it know, that's what you're saying. First girls sat, and then you identified the potential gaps for the boys, and then you made the boys occupy those particular gaps. Now this is the point. That's how the work problem looks there. That's how the problem looks there. Fair enough. Let's now take the circular table. Now the 4 boys, 4 girls. Same question, friends. Second one. Same question. What is the table here? Circular table. The table is a circular table. Same thing happens there. Same thing happens. 4 girls. 4 girls. Now first the girls will go and occupy these particular tables here. Girl 1, or let's say girl 1 is here. Girl 2 is here. Girl 3 is here and girl 4 here. Why? Because no 2 boys should sit together. If no 2 boys has to sit together, then who should be separating them? Girls. Therefore I'll give 4 chairs to the girls. I will say that hey girls, please go and sit around that particular table. 4 girls went and sat around this particular table. 4 girls who go and sit in how many ways, friends? 4 minus 1 factorial way. Because whichever the girl goes first and sits, now that girl forms the reference. Girls form the reference. Then the other girls will arrange around that particular girl in 3 factorial ways. That's what you mean by 4 minus 1 factorial. This is what the girls now have taken the positions. The girls have taken the positions in 4 minus 1 factorial ways. Fine, the girls are seated now. So what are the potential gaps? A boy can sit between these 2 girls. Another boy can sit between these 2 girls. Another boy can sit between these 2 girls. Another boy can sit between these 2 girls. Now the girls have sat. Now the boys are coming into the picture. How many gaps are there? Only 4 gaps are there. That is 4C4. Only 4 gaps are there, right? How all the 4 boys has to go and sit here in 4 factorial ways. Now may wonder, hey, why 4 factorial? Isn't it again 4 minus 1 factorial? No, reference is made only once. Reference is made only once. When the first person is going and sitting, that's when the reference is made. After that, no more references, my friends. Only 1 reference is enough for counting. I don't need 3-4 references for counting. 1 reference. Basically, these problems are about what? Counting. 1 reference is already made by writing 4 minus 1. The minus 1, that one is nothing but the reference. reference only. You made the reference, therefore you arrange the girls in 4 minus 3 factorial. Just now identify the gaps for the boys and then make the boys sit into that particular gaps. Now that's a difference between these two questions, right? Circular and linear. I hope all of you got the perspective about the elements that I discussed today. I started with fundamental principle of counting. I made about 4 or 5 points there in the fundamental principle of counting, right? Then I established the relationship. I went ahead and spoke about the relationship between permutation and combination, which means selection first and the arrangement of selected ones. So let me know how important is that particular concept. Then we talked about the circular arrangement. We talked about the linear perspective, circular perspective, and we talked about the vertical perspective and horizontal perspective. Then finally we closed it with gap method and string method. These are all very far more elementary topics I discussed. So when I talk in the next lecture, in the next lecture, we'll try and capitalize on some of these concepts. Of course, we'll study a little more about the selections in that chapter, and then we'll go back and establish, we'll hit a little bit of depth with the applications in that particular lecture. Right, that's about it for today. I hope everybody enjoyed it, in the sense all of you learned well enough some basics. Nice revision of the basics has taken place. Consolidation of the basics has taken place. Good guys, I will see you with my next video. Bye till then, stay blessed.